Oh, Daniel here with the Virtual Robotics Studio, and we're back. Normally, we would finish the entire robot before wiring, but because of the way this robot's built, once you put the hopper in, it's going to block access to a lot of stuff. It's going to be easier for you to see what I'm doing if the hopper's not on top of the robot. It'll also be easier for me to reach inside and do the stuff. Now, you can remove the entire belly pan of the robot, but it is a lot of rivets to drill out and a few bolts that you'd have to take out to do that. Do the electronics on that polycarbonate sheet outside of the robot and then mount it back in. But I think since we're kind of ready, we have all of the Swerve motors in place, and that is a bulk of the motors that we have to wire. We will have 2 more for the fuel mechanism, but we can even get those speed controllers set up and ready to go. So we're going to get all of this stuff put into the chassis of the robot, but before we do, we're going to give a special thanks to Argosy. First, Cross the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School, for hosting our studio. All right, so our first step is going to be to lay stuff out inside our robot on the belly pan to figure out where we want to place it for the wires to reach and just have room for everything to mount. But before we get started with that, I do have one spare Swerve module here, and this one is the way that yours are probably going to look. So the ends of my motor wires right now are not stripped. And they'll be about this long if you use the pre-made cables. Now, you can get different ring terminals, and you can make your own cable any length. That's one option. We're going to use the pre-made cables because I think making sure the ring terminal connection is crimped well is a little bit more tricky than throwing a connector on the end of these. All right, so we have those wires coming out. And then for all of our CAN wires coming out of the motors, right, they're going to have these little connectors on them. And they have 2 pins coming out on one of them. And the other one is actually the opposite side of that. So these are connectors that could actually plug together. So one of the ways that you can wire this up is by plugging these 2 things together and then maybe taping it or finding some way to stop them from coming apart. And that can work, but it's a little bit better if we use a more positive locking connector. So what you'll see on a lot of the Swerve modules that I have in the robot, these are the same Swerve modules that we used when we did our demo Swerve videos last year. So I can't replicate the same wire state because we've already cut a lot of those connectors off. So when we get to some of those ends and I already have cut and stripped wires, just know that if yours are this way, you can always make the choice to use this connector and plug it in, or you'll have to cut and strip your wires as we go. So I'll have a few of those that are shortcuts for me. There are a few that I'll still have to do, and we'll talk about those when we get to it. And then same thing for the CAN coder here. That looks like it comes with 2 wires that are the power wires that already are stripped. I think yours will come the same way. And then it also has the 2 yellow and green CAN wires with the connectors on them. So I'm going to put this one aside. We can bring it back for reference if we need it. But just keep in mind that on mine it might look a little different because of that. All right, so we need to find a place for our RoboRio. The other big thing that we're going to need is our power distribution hub. Or if you have the Cross the Road Electronics Power Distribution Panel 2.0, that's going to work as well. I think this one came in the kit of parts, so that's what we're going to throw in here. And then finally, we will need 2 of these SparkMaxes, which should have come with the KitBot crate. So these are going to need to get somewhere, one for our intake motor, our roller and launcher motor, and then one for the feeder motor that sends stuff up to the to that launching wheel. And in these boxes, by the way, like I'm pulling out the main part, but there is a yellow and green wire set that we're going to need later. And there's a little plastic piece that we're probably going to use at some point. So don't lose all of the extra stuff. We're still going to need it. But we don't need to find a place for that in our kind of layout period right here. All right, and then from Cross the Road Electronics, we are going to do, so basically the idea is with KitBot, we get kind of the 2 sim motors that we have to power. And I think these SparkMaxes came with that. to power them as part of the KitBot. So we're going to use that for the two KitBot parts, but we're going to do things a little bit differently for the drivetrain. So the drivetrain, there is something that we're going to use called a canivore. And the canivore is basically something that we're going to plug into our RoboRio with a USB cable. And this is going to create a second CAN bus for us to use. And this is actually going to use something called CAN FD, but it is a faster version of the CAN bus. So we're going to be able to send more information back and forth quicker. Updates will be faster, and it tends to be a little bit more reliable as well. So we're going to use this to control all of the devices that we can control with it. Now, those devices are only the cross-the-road electronics devices. This one did not. I already put power wires in here, but we'll take those out later. All right, so this one is going to control all of our Swerve motors for steering and drive. So we're going to get all of that connected together. We're also going to be able to connect all of our sensors in each corner, our CAN coders, to that as well. And then the last sensor that we are going to use, again from Cross-the-Road Electronics, is the Pigeon 2.0. So this is what we call an IMU, or inertial measurement unit. This basically has a bunch of accelerometer and a gyro inside, 3 gyros inside, that will measure the movement of the robot, basically. So it'll measure if it's rotating, if it's rotating in any plane, pan, tilt, and yaw. And then it also has accelerometers to measure movement forward and backwards. So by using this, along with the CAN coders in the corners, we're going to be able to know what direction the robot is facing at all times. And so the controls for this robot are going to be what we call field-centric. So if you push forward, your robot is going to drive forward away from you. If you drive backwards, it's going to drive backwards away from you. What this will let you do is rotate while moving. So if you're driving out to the middle of the field to load some balls, and you have to then turn around to be facing the right direction to launch the balls into the goal later, into the hub later, you can actually be driving back into position while rotating and spinning the robot around, and it's going to stay right on that line as you drive. This will also be necessary for you to get your auto modes in. So using the sensor in auto mode is going to do a good job of helping you follow your paths more accurately. So we need this. We want to mount this close to the center of our robot if we can. And that's, I think, and then the main power switch. And that's all the stuff we have to find kind of a home for. So we got a lot of room. Usually I start with the hub, the power hub, whatever that's going to be. And we just need to figure out where we can put it in the robot that will let as many wires plug in as possible without needing connectors. And what's nice is I think I could be even all the way against this bar and maybe still use it. It's a little tough. It's just a little narrow in here. It is possible that like flipping it around could be good. We might be able to get some extra space that way. It could maybe go even all the way out to the side here. Could work. Now, I think we do have a little bit of a problem because putting the power switch in the middle, there are inspectors that are going to look at your robot and they're going to decide, hey, that power switch is not in a good spot, accessible spot, so that would not be safe. So we can't put it kind of buried here, but we could move it to the side. We could even move it, off to the side of our battery mount as well. Let me kind of shove these wires out of the way so they don't keep blocking where I'm trying to put stuff. So this is an option, right? You could reach in from the back and turn that on and turn that off. That would maybe let us put our power distribution hub over here. Maybe over a little bit. But then the small ones, which we're going to use, are a little bit harder to access. So, I could see maybe something like this. This gives us a lot of really accessible spots. And then I think we could still get to these if we needed to. I mean, we can just see, right? Like, can I plug a wire into here at this angle? And the answer is yes, for sure. It's not easy, but it does seem to work. So I feel like a position somewhere around here might be good. And then we can maybe put the switch off to the side like this. And then we have our RoboRio that can kind of hang out on the other side, something like that. And so I guess the thing that I want to check here, though, is Okay, so obviously on this side, these wires reach, and these wires reach. So our front right module, everything reaches. The front left module, it's right there, so everything's going to reach. Do the other side of the robot modules reach? So this is the farthest wires on our back left. And can we get those all the way over to one of the ports here? And it looks like, yes, we could go around our battery box, and we have plenty of room to plug those in. Can we get our front left modules to reach is the most challenging one. And that's not even close. So we can do one more check here before we select a position. And that is, if I take the wires that are the farthest forward here on this module and bring them down. And your wires might be a little longer than mine, right? Because they were cut once. But it looks like if I don't want to go on a straight diagonal through the air, which you kind of never want to do, we're going to sort of route these down along the frame or into this frame rail here or down to this frame rail. We can't really get much closer than, I would say, like here. If I move this all the way over to here to plug those wires in, the wires from the other side aren't going to reach. So no matter what, one set of our drive motors are going to need to get extended, which means that position, I think, is pretty solid. Now, on the RoboRio, if we're putting this here, we can attach it kind of in any direction we want. We do know the robot signal light is going to end up, well, I guess we can switch which side of the robot signal light goes on, right? Because the fuel intake has stuff on both sides, so that doesn't matter. CAN is going to have to connect to the power distribution hub. We might want to plug stuff into here. So this is the only thing that changes things for us, is we might at some point want to be able to access these two ports. And so inside the robot is a little bit harder than outside of the robot. But remember, our fuel intake and hopper stops kind of at this width. So this isn't even that deep. We could maybe rotate it around this way and do it as well. It just means our power wires are going to get a little longer, and our CAN wires are going to get a little longer. I think I like this direction, because basically all of these wires are going to be heading in this direction for us. That seems reasonable. And this can get pretty close to this bar, because it's just the CAN wires that we would have to access there if we're going to access anything at all. So something like this is pretty good. What this lets us do then is it lets us put our pigeon somewhere in this neighborhood, which is like, that's pretty close to the center of the robot. I'm just eyeballing it. I don't think it has to be precisely, exactly, perfectly in the middle, but I think it works a little bit better if you're close to the center. And I would say the center of the robot is probably right here. So that's very good. We could even sneak this over a little bit. We have to be careful, though, because I don't want to have to extend these wires. So I'll probably end up attaching these wires and then use that to figure out the specific position of this. But we can get that pretty close to the center of our robot. And then our canivore is going to need to plug into the RoboRio and then just be part of our CAN chain. What'll be the start of our CAN chain. So this could also live probably somewhere in this area. We have plenty of space there. And then, in order to power our two intake and launcher feeder motors, intake, launcher, and feeder motors. Yeah, that's because the one does two things, right? So we can definitely throw one of these on the side here. The only problem with that is it will not plug into our ports. So if we want this to be able to plug in directly, maybe we can sneak that over a little bit like this. So that would let us plug in here, which seems pretty reasonable. And then this one could maybe go here, either sideways or this way. That could plug in, and then we'd have these wires looking to connect up to our hub. So that seems pretty straightforward. I don't think we're running into any problems. We may want to adjust the position of these once everything is in and we know where those wires are going. But I definitely like the idea of not having to do connectors if we don't need to. So a position like this seems to make a lot of sense to me. All right, so if we're happy with that, then we can move on to starting to stick all of these things down. Now, This layout, there's so much extra room here. Like, I do not feel like I'm pushing hard to fit everything in this space, which means there are probably 100 different ways you can lay this stuff out and have it work for you. The big thing is try to minimize your connections needed. Try to keep the pigeon near the center of the robot, and the rest of it is your preference. So if you want to kind of lay stuff out differently, that's completely fine. All right, I am going to mount pretty much everything with this dual lock, this hook and loop that came in the KitBot crate. This stuff is pretty strong, especially if you use a nice long piece of it. Even for the hub, even for the RoboRio, like using this stuff feels very secure. The only things that I might want to do differently, and I probably won't, but I might want to, is the pigeon. If you find, like, when we did the regular KitBot, this stuff, like, the pieces were not shifting around at all on me. If you find that the connection seems not great on the pigeon and it feels like maybe it can wiggle around a little bit, that could maybe affect the accuracy. If it looks like that's moving or you look like you're running into those problems, there are holes here for bolts that you can drill through and bolt it directly to the plate. So that is, if you're running into problems, one of the troubleshooting methods. But I think this stuff, the way it felt, I don't think it's going to move. So I'm going to just stick with that for that. And the only other thing is the power switch. And this one, there are a few different power switches, by the way. This might be a old model. I think they're all the same size and shape. But I think there's a couple different companies that make them. So if yours is differently labeled, that's probably good. This one I just grabbed from an older bin, so I had a second one because I used this year's one on the regular KitBot. But this is going to have big, heavy battery wires connected to it. You're going to be pulling those wires and plugging them in and unplugging them. And for this, I find that a lot of times the Velcro will start to come free, or the hook and loop will start to come free. So with this one, I will probably try to get at least one. Maybe we'll drop 2 bolts through to hold that in place. The nice part is this hook and loop is just long enough that if we stick it on the regular flat side, it, I think, will stick and touch the board. But it has these sort of raised posts in the corner, which makes it also hard to rely entirely on just your adhesive stuff. All right. So let's go for it. I'll start with, I guess we'll start with this, with our main power distribution hub here. I'm just going to kind of give myself, I'm leaving just a tiny bit of space between this bar and where it is. And that seems pretty good. Now remember, because all we're doing is going to be hook and looping it down, like we could lift this up and even shift it over slightly and put it back down. But I want to leave myself a little bit room just in case I have to adjust this later if I find out, oops, I made it too close. So I'll leave, like, I don't know, between 1/8 and 1/4 of an inch maybe. And that feels like a good spot. All right. So then what I'm going to do is we'll flip this over and start cutting some long strips of this dual lock stuff. Yeah. I'm just going to do 2 long strips the entire length of it. That feels like pretty good. So we'll do 2 identical ones here. All right. And the cool part about this stuff is it's not a fuzzy side and a rough side. It is the same on both sides, which means I don't have to worry about getting, the right polarity of my Velcro in case I have to replace stuff. All right, we'll just run that strip down. I'm going to not cover the corner holes because there are corner holes here as well that we can use to add bolts. So with this as well, if it feels like it's not staying put for you, I would probably just add more Velcro first, but you could add bolts as well. Just if you can get away with just this, it's really easy to replace things, to move them around, to take them out if you need to get access to plug a wire in or unplug a wire once the whole robot is together and it's hard to reach stuff. To give yourself the best chance of this sticking, if you do have some rubbing alcohol or something like that, you want to kind of wipe off the area that you're going to stick it to. You don't want any of that. I got some wood sawdust, looks like we got some of our plastic powder down there. That stuff will make it not stick quite as well. I don't have any rubbing alcohol. You could do some water as well, but you just want to kind of try to make sure the surface is clean before you stick it down. All right, and then I'm going to do this with the power facing to the right, facing towards where my switch is going to be. And we're going to shift it over, but leave, wait, just a little bit of room between it and the battery mount here. And then we'll push it down. Now, the one thing with any of these adhesive things, Velcro type things, is don't immediately rip this up. That glue takes a little bit of time to set. So if you stick everything down later, like the next day or after a few hours, then you'll be able to pull up. And it looks like not too bad. Then you'll be able to pull up and have the Velcro pop instead of the adhesive peel up. But that seemed to work okay, so probably in good shape. Means we got it, clean-ish, clean enough. All right, that's in place. Then, what should we do next? Let's get the pigeon in place, because that's kind of the next thing that we care about being in a specific spot. And I'm going to just give it plenty of stuff, because I really don't want this one to move. I'm not going to cover the holes, though, so what can actually happen is, if necessary, I could maybe just put bolts through the holes without having to remove the hook and loop. But we'll go ahead and I think I'll put these on one at a time. So I'm going to go not covering the hole. Then we'll do a strip down the middle. And then one more on the other side where we don't cover the hole. It's probably fine to cover the hole too. Worst case scenario, right? You just have to peel it off. And make sure that's squeezed on there and set. All right, and close to the center. I'm not going to make it touch the other thing, but I'm going to get very close. And, okay, I'm going to give into what's it called? Now, our robot is 24 inches long, but as far as this is concerned, the bit past where the wheels are doesn't count. So really, it's 24 inches is what we're looking at. So if I measure from the back here, we're looking for 12 inches. So I'm going to try to put the center of this at about 12 inches. So that was a little bit farther forward than I thought. And again, I'm going to be close but not touching, which means I will be, maybe half an inch off center. That looks close enough for me. And really get that set in there. Looks good. And the other thing to think about too is it does not feel like it's shifting at all on me with this particular stuff attaching it. In fact, most of the movement is the plate that we have here, the polycarbonate sheet, our belly pan. So any kind of vibrating is probably coming from the polycarbonate and not from this thing being, I don't know what this stuff is actually called because it's not labeled, but this Velcro type stuff. All right, that looks good. We have room for some wires and stuff there. What should we do next? Do we want to put this? Well, let's see. So if this is going to plug in, well, okay, we have these wire motors that are going to come over that we're going to have to extend. If we're extending them anyway, it doesn't really matter which one we pick. So we could either put this one into the kind of third spot in here, or we could do it in the first spot, but that doesn't really gain us much in terms of positioning. So I think if this is going to go into the third spot, it's getting a little tight. Let's see, red, black, red, black, red, black. So the third spot would be here. Yeah, I think that's okay. So I'm just going to put this close to, but not quite touching the pigeon that we have here. So I'll take our first our first of our fuel mechanism control items, our controllers. I'll wipe that off. Not sure why I picked up the tape measure. All right, and we'll do, let's see, do we want 2 strips this way? 2 strips this way? I guess I'm going to do 2 strips this way. That seems reasonable. All right. Measure that off. And we want 2 basically the same length, so going to be right about there. Peel and stick, peel and stick. Okay, and again, we can always extend wires. We can always change which one this plugs into. But I want to make sure, or I want to try to get this to the 3rd spot here. So if it can reach that with a little bit of slack, then we're pretty happy. So that means I'm going to go basically as close as I can to the pigeon without touching it. That seems reasonable right about there. So I'll stick it down. And I'm also just barely not touching that front bar. Okay. These things down, get them out of the way. Then it seems like next up we can go with where to put the RoboRio. And really, we have so much space here. I might leave some space to the outside so you can mount other stuff there if you wanted to later. Seems like a reasonable spot. I'm going to leave room, like sort of a channel here to fit stuff, and I'll leave a little bit of space on our polycarbonate to the outside as well. So if I needed to route some wires or zip tie some stuff down, I'd have some space there. And we're going to try to run everything on top of this panel because, again, going over the bump, this panel may drag on the ground. So we don't want anything underneath it that could get caught. So routing wires underneath especially would be bad because if you catch and drag wires, that is going to be a serious problem. All right, so we'll flip that one over. And I don't know, add some more stuff to the bottom of it. The RoboRio is pretty light, right? So that helps. On the sides, there are these slots, and that's actually for these zip ties to mount it. So once again, I'm not going to block the slots when we put stuff down, but I think there's also tapped screw holes as well if you prefer. But I think if we just do 2 nice long strips here, it's gonna be good. Just do I want to go? I am going to cover the screw holes because I believe that I will not use them ever. But if you think you might use the screw holes, then just cut your piece a little shorter so as to not cover it up. Say I'm only going to cover half of it anyway. All right. So we'll cut a couple long strips of Velcro for this. Again, if you go to put this in and it feels not secure, add a 3rd strip, no problem. I think we're using less than KitBot used, and KitBot had enough to mount all of this stuff and to mount some extra SparkMax speed controllers and to attach the flap on the back of the robot to keep it from moving. And we don't have that flap on this robot. All right. And basically anywhere in this neighborhood is good. So, find what feels good to you and stick it down. Yeah, that's, I mean, I don't think that's going anywhere. I think I can almost lift part of the robot or tilt the robot by lifting up on these things. So it is a good connection. All right. Up next, we got our carnivore. And that, we said, it's going to have a USB cable to our RoboRio. So any of those slots is fine. And then the other end is going to have to plug in here. So we can kind of decide, like, do we want, you know what I mean? Do we want like our extra wire to be this way? This way? Well, I don't really want to block the lights on there. And we're going to need to access this stuff, but with these, because it's going to be just Velcro down, we can lift it up and then hit those buttons to put in or take out stuff. I almost feel like this is kind of like a good way. It feels like that USB cable has a good spot to sit down here on the belly pan. And also, there's no sharp bends in this, right? If I try to put it like right next to stuff and there's sharp bends everywhere, I don't like that either. So I kind of like going around this way where we have a little bit more space. Let's see. So 2 of the wires here are going to go to power over here somewhere. No problem. We got plenty of room for that. And 2 of them are going to be the start of our CAN journey, which is also fine because that can go maybe to this module, through the pigeon, through this module, and then it stops at this module. So I think that's fine. That's a good spot for it. It's just maybe we want, the only change is maybe we want the wires on the inside. And this towards the outside a little more. And I'll probably I got a zip tie already on there, but we can adjust how much of this wire we need to be able to put this wherever we want. I'm pretty happy with this. We can do a little something to tie these wires down here. Keep them out of the way. They'll stay nice below the hopper basket. Just make sure I have enough room here that I'm not over kinking that cable, over twisting that cable. So something like that feels pretty good. All right, I'm going to unplug the USB for a second. And I'm basically going to be just about lined up the hole to the rivet for me. But if it helps you just to know, like, okay, this was a spot and I'm going to flip it over and put Velcro in, you could do like a little, we're going to line up there, we're going to line up there, and then you've got your spot that you can go back to. All right, let's flip that over. All right, and give me a second. I apparently have already put different Velcro on this one. So let me get that peeled off. Oh, wow. Okay. That was way less bad than I thought. That just peeled right off. All right. So we're going to do 2. Again, there are bolt holes here that you can use if you want. I'm going to stick with not needing them. So I will still not cover them up, though. So I'll cut this short enough to not cover those holes, and I'll do 1 strip on each side. This one, I think 2 is enough. Honestly, even with the pigeon, 2 is probably enough, but I felt compelled to do a little overkill on that one. Let's peel it off. Stick that on one side here. And then get our other one. Stick that on the other side. All right, and then I want the USB cable to be facing away from the RoboRio. I got a lot of dust in this area. Let me do my best to move it out of the way. All right, and then I can use I missed. Gotta be careful that it's lined up and you go straight down. Somewhere around there seems fine. All right, that is in. And then, like I said, I know I also said don't immediately take it off, right? But when we need to get to these wires, if it's hard to reach those wires, I mean, I don't care because we can just pop this off, put the wires in, and then stick it back down. So that's going to be fine. You might, moving it a little bit more, even doing this on a small angle might have been slightly better. I'm not sure. There are, like I said, plenty of solutions to this problem. All right. And then we've got our main power switch that we're going to work on the other side here. Now for this one, I kind of like making the wires as we go so we can feel like these are big, heavy, grab those parts, but these are big, heavy 6-gauge wires. And the pieces that you get in the kit or with, I think they were in KitBot crate, this is just, it's very stiff, it's very heavy, it doesn't want to move a lot. You can't really bend it to a very tight radius. And what we need to do here is we're going to have one, which is our main battery connector. This, the black wire, is going to plug directly into our, in fact, we can just do that. It's going to plug directly into our power distribution panel here on the black side. Right? And then this is going to head this way, right? And our battery is going to be over here to plug into it. So that's good. And then the red wire, one side of the red wire needs to go to the power switch. So it feels like maybe a power switch location out a little bit more is going to be good. So this is going to go into the power switch over here. And then the other side of the power switch is what is actually going to go into the power distribution hub or PDP, whichever one you're using. So like, you know, a little bit of wire doing that, maybe we can get it to do that. So some position like over here, maybe bringing this back this way a little bit gets it a little bit nicer. Gives us a little bit more room to loop out and come back to where you have to plug it in. So I think that's what we want to do next is this wire. If we make this wire and we actually attach this electrically, then we'll kind of feel out how those wires are going. We can kind of move it into a good position and tighten it down. Although you could put this in first, it's going to kind of work either way. So what I'm going to do here is go kind of off to the side here where I got some free space. And we need to cut and strip this wire, and then we need to put one of these connectors on. So we've got these ring terminal connectors here that we're going to use. So we need to put one of these on one side, and we're going to need a second one for the battery power, the battery switch to get, the battery plug to get attached on the other side. So with this one, there is a world where you might want to cut this to get a different length, but I usually just leave this alone and just put the connector on. So if we take the red side and slide the ring terminal onto it, we now need to basically crush the back of this housing down all the way as much as we possibly can. And hold on, before, well, nah, this is fine. Yep, we're good, we're good. All right, so we need to crush this down as much as we can. I have sort of a long-handled pair of crimpers here. That's what we're looking at. So these, I can really get out and squeeze a lot. My hands can get back on there a lot. So if you have that, that's great. You can pick these up. I think most hardware stores will have something like this, but you want to get the biggest, beefiest crimper you can get. And it's got sort of like a spot in the front where there's like a single tooth that's going to crush down into the housing. So that's what we're looking to do on this. If you don't have that, I have seen people be successful trying to crush it in a vise. I've seen people be successful. I mean, maybe you can pound on something like a hammer and like a chisel shaped thing. But you need this to be really tight. All of the connections on the main power line need to be as good as you can make them. Any looseness here at the main battery is going to have major problems later. So if you have a loose connection, what that does is it increases the resistance in that connection point, in that junction. And if you increase the resistance, it's going to basically increase the amount of voltage that is lost going through that connector. And when the voltage goes down, that means in order to do the same thing with your motors, the current has to go up. And so sometimes what can happen is if you have a loose connection, things won't work quite as well, but also your battery voltage may dip. And if it dips low enough, things like the RoboRio can reset. If your computer, which is the RoboRio, resets, your robot's not doing anything for a while. So make sure these are as good as you can do. All right, so on this, there's sort of like two sections here. There's two blue lines and two sections. I'm going to go in the middle of one of those sections, and I'm going to just squeeze literally as hard as I can. I guess some of you might be enough stronger than me that, no, I don't think you can squeeze too hard on this. Just crush that absolute crap out of it. All right, and then I'm going to move over. I'm going to do the same thing on the other side of the line. So we have kind of 2 points there, or 2 places where we've crimped down as tightly as we can crimp down. Okay, and then you want to basically pull on this connector, wiggle this connector. If it gives you any feel like it's moving or slipping, then crimp it again. Mine is not moving. All right, so that's one side. Now on the other side, we're going to be using just the regular red wire that we have, and we have to find some way to strip this wire. So you can potentially use just like a regular set of cutters and try to get that going. If you have a set of wire strippers, that might work for you as well, which I have over here. But usually these wire strippers, like this is too big. The biggest I can do on these is maybe 10 gauge wire, and this is 6. So this doesn't really fit. Even if you have the regular ones that you squeeze on and you have to twist and pull, those you probably won't have a 6 gauge spot. With those, sometimes you can squeeze on and turn it a little bit without squeezing all the way and get it to go. But what I like to do is use either a pair of either flush cutters or diagonal cutters. Flush cutters are usually too small, but you can sort of squeeze in and do some cutting and rotating. You could probably do it with a sharp pair of scissors as well. You can get it started and just sort of like cut in from a bunch of different directions. For me, I usually use a utility knife. And I find that if I put it in and I just kind of push and roll the, be careful obviously with your thumb. So I'm just slowly rolling the wire around. You can then start to peel the wire, twist the wire, and you can see where that cut is starting to show up. And I can see where like that cut did not go deep enough on whatever side. So then I can go back around on that side a little bit. I can look on this side. Okay, like here, I didn't quite connect the 2 cuts together. So I got a little bit of a joint there that I want to get into to connect them together. So then we can continue like that. And at some point, like as you start bending it, you're going to start to see the metal wire showing up. And that's what you want. So we got metal wire there. If I tip this way, still metal wire. This way, I've got some plastic still in the way. So I'll know, that's a good spot for me to try to cut that plastic out. And looks like over here we got a little bit as well. Okay, and now when you can sort of just see it's metal all the way around, you don't see any more plastic holding on, you can start wiggling that and pulling. You might want to get a pair of pliers of some kind, and that can work too. You can kind of grab in there and try to get that going. All right. Now that side's stripped, we're going to take another one of those ring terminals that we had, and we're going to slide it on. And in this case, I was off by a little bit. So you can see with this pushed all the way in, if I can hold it still, there is some space in between the insulation and the ring terminal where I can see bare wire. I don't want that. So what you can do is you can then trim the ends off to get it a little bit shorter. You want it to basically, you want this to slide down and bottom out right as it's hitting the insulation. And it looks like I was maybe 1/8 of an inch too far. Now, you might have something that's big and beefy enough that can cut all of these at once. That's fine. But if not, it's okay to just sort of like, grab some of them and snip it. And then keep going with the next little group and the next little group. And you want to be careful. These, depending on what cutter you're using, can send the pieces flying. So, when I'm cutting this, I'm cutting it so that the open section is not pointing at my face, because the pieces will go flying a little bit. And obviously, if you have other people around you, you want to be careful for that as well. All right, now we can slide that ring terminal back on. And it is good. That is bottoming out. And once again, we're going to, let me put this down on the table here. All right, we're going to crimp that in the first blue section as hard as I can. Maybe even lean on it on the table. And then the second section as hard as we can. Okay. Seems pretty good. All right, so now if we go back to our main breaker, we have these two metal posts on the side with nuts on them. That is where this is going to screw on. So we got to be able to take those off. I think those are 7/16ths, and you can use a 7/16 wrench. But if you have a socket, that is going to be way, way easier to use. See, did I grab the right one? Yeah. So with a socket, it just sort of can reach down around the bolt nicely. With a wrench, you don't have much room. You can do it, but you got to do it kind of a little bit at a time. But either way, once you sort of break it loose, you can spin them by hand to get them off quickly. And I'm going to take these off, but don't lose them. All right, this now, let's see, do I want the switch this way, or do I want the switch this way? So the only thing that changes, right, the posts don't matter. They end up in the same spot either way. The only thing that changes is where the on part of our switch is. So this turns it on, this turns it off, and I literally don't think it matters. For some reason, I want to put it this way with the power switch facing forward. But yeah, I can't tell a difference here. All right, so what we're going to do is we're going to put this ring terminal on, and we know we want it to be sort of coming out in this direction. We'll probably end up even bending this up a little bit so it can come up and join the other. Wait a minute, that's the wrong one. That is the side that the one attached to the power switch is going to go on. So make sure you have this one that is the Anderson connector with the power switch on it. That one we're connecting on the inside of the robot towards the battery mount. So we'll get a nut started there. Okay. And we want this to be pretty tight, but right now I'm going to leave it loose so we can make some minor adjustments after we have everything mounted. And then the other one, this one is just the wire, and it's just bare wire on the other end. We haven't cut it down to length yet. We can put on the other side, and I think is this better? Yeah, that's a little bit better. So I'm going to go, is that going to sit flat? I think so. Okay. So it looks like the ends are pretty big. So if I put it on facing out, that works. But you can only rotate it so far over before the metal hits the end there. You can put it on this way, no problem, but that's the wrong way for us. That's not the direction we want it to go. If you put it on this way, so it's going this way, it's going to hit that ridge, and it's not going to tighten down all the way. But I think if you rotate it just as far as possible out from that ridge, we're going to be able to get a good solid connection. And I think that's sort of the best direction for it to go. But before I do that, it's going to be hard to insulate this connector after it's on and screwed in. So the other side is a little bit easier because it's still accessible, but here we're going to be right against that ridge. So I'm going to grab the red and black electrical tape. Well, just red really for this step. So I've got some red electrical tape here. And I'm going to just kind of wrap that wire for starters. So I'm going to take it off of my post here. Easier said than done. Okay. And then I'm basically going to not cover the flat section yet. We're probably going to have to add more tape to cover that, but I'm going to start just above the flat section. Okay, and we're just going to go around this a few times. And then up into where the actual wire insulation is. And if we go up into the and cover up the red part of the wire, the insulated part of the wire a little bit, that'll give us a little bit extra support for that joint. So no reason not to do that. And then you can rip electrical tape, but it kind of stretches when you do. So I do usually like to use scissors. You get a cleaner end to it. All right, that looks pretty good. Let's now go back onto our power switch the way we were talking about. And then let's see what happens when we tighten this nut back on. We're going to be looking to see if we were able to force it down so it went all the way flat. If it doesn't sit all the way flat, we're going to have to take it off and change the angle of our connector. Now, also this connector that we have here, this ring terminal, you could go and file the corner just a little bit to get it to rotate a little bit more, and that would probably be okay. But you need to be careful not to take too much off, right? Because it is sort of rated for what it's rated for based on how it's made. So we don't want to change it a lot. All right, that is getting tight. I'm going to go ahead and tighten that, not as tight as I can, but pretty tight. Because again, we can't have any loose stuff here. Now, these studs that are built in, if you really go hard, you can break the stud off. So that's why you don't want to, this is not a crimp it as hard as you can situation, but this is a make sure it is tight situation. And you can feel now on the wire, if you can get it to wiggle at all, it's not tight enough. But mine is not moving. And I'm kind of just looking on the edges here, and it looks like it is down and it is completely flat all the way across. So that is a good connection for what we're looking for. All right, and then ultimately this is going to sit over here somewhere, right? And so this wire is going to have to bend back up and go into there. And that seems pretty reasonable. Somewhere around here. Looks like that's going to work out well. If you're too close, it doesn't work. So I'm getting pretty close to the outside frame of my robot to sort of feel like, yeah, that's doing it. And I'm going to kind of route the wire the way I want and measure to the end of this terminal. And that's where I'm going to try to cut the wire. So I kind of have a mark here. That's where I'm going to try to cut it. I'm going to use, I have some cutters on the end of those crimpers. That's the biggest, beefiest thing I have to hopefully cut this wire. And again, if you don't have something that will go through it, which this might not, oh, it did, it took a lot, then you can just, again, cut it in pieces. You can cut halfway through and then keep going and then cut through more. All right, now we can go ahead and we can strip the wire to put into this connector. And one thing that is on here is there is this gauge here, which shows us how much to strip. So it wants about 3/4 of an inch of wire stripped, but there's this little like measuring unit. So if I put that next to it, that's about where we want to strip the wire to. If you're a little bit longer, a little bit shorter, that's going to be okay. But we could maybe just do a little dot in that region. And that is where we're going to start doing our wire stripping. And I'm going to do the same thing that I did before. This is all, everything's all connected now, but I'm going to do the utility knife. Method here. All right, just trying to keep it level so it goes back into the same groove. And then once you go around once, you can start peeling it back to see what's going on. It's almost there. And then let me get those pliers back out. Oh, not enough to collect the pliers. So, you know, I'm kind of just bending and pulling the best I can. Sometimes you can get, oh, I have a little bit of plastic left. Maybe that was part of my problem. Sometimes you can put the pliers inside as well and sort of like push on it to get it moving a little bit. I think when you can grab on the outside edge, that helps. It's moving. There we go. All right. So now we can plug that in. So lift up the orange tab. There's a hole below it where you can slide the wire in and then just drop the tab down. And then we can sort of see where this would end up, right? So I can give that wire a little bit of that twist that we were talking about. And it looks like we're going to be somewhere in this neighborhood for mounting. Getting much closer than that is going to put a lot of strain on the wire. So that feels all right. Okay. So now we can try putting some of that Velcro on here. That might be nice because it'll kind of hold it in place for us, even if we go and do the bolt afterwards, which there's a good chance we're going to do. So let me get a strip that is about the width of this thing. Actually, I'll do 2. We can see how the 2 feels. It looks like there might be room to do a third one. So we'll see how the 2 feels. If it feels close, then maybe we'll just add the third one. But I think I'm gonna, this one I think I'm gonna drill and add some bolts to it as well. All right, so we've got our 2 strips. Let's go ahead and peel. I can't do it. There we go. All right. Put that on there so it stops fighting with me. All right, so find our spot. Somewhere around there. Yeah, see, that's what I'm worried about. Let me get that back on. So it's definitely holding its position now, but as soon as I grab the battery cable, right, and twist the battery cable around, it pops up in the air. And I don't think another strip is going to help with that. So we probably could have skipped the hook and loop and gone straight to bolting, but I think if I can get it attached back on there, at least that'll hold it in place for us while we go and screw it in or bolt it in. Okay, so then let's get a drill. And we're going to be doing the same bolts that we got with the KitBot hardware stuff. So there are, I think, some 1-inch long bolts, and we'll see if those are long enough. And then the associated nylock nuts. And then because we're going to use those bolts, that would mean you want kind of like a number 7 drill bit, that 3/16, 0.196, 0.201, anywhere around that neighborhood. So I've been using a number 7. I'll keep using a number 7. And the question is, will this be long enough? This is going to be insanely long. Let me grab also the half-inch long bolts. We got a few of those left over. I think you probably should too. And we'll see which one is long enough in a second after we drill the hole. All right, so really all I'm going to do is just put my drill in there. There's nothing electrical in this area. This area is just plastic, and this area is just plastic where the stuff is getting mounted. So I'm just going to stick my drill right where it is and try not to touch the sides, try not to run into the piece that's there, and just drill through. And so we'll do that on one side and on the other. And since our belly pan is made out of plastic, I don't really have to worry about shavings. Plastic shavings are not conductive. So, we're fine with them being there, with our electronics being there. All right, the half-inch bolt, it does not make it above the top at all, so that's not going to work. I was right. The 1-inch bolt, though, should be perfect. And by perfect, I mean probably a little bit too long. That is out nicely. Now, the nut is a little bit small for this hole. I think these holes are actually for 1/4-inch bolts. So just to be safe, and you can probably just put the nut on with nothing, but I'm going to add a little washer there just to make sure it grabs in nicely. And get that started. Whoop. I dropped the washer. I dropped everything, technically. Okay, that one started. Let me go ahead and get the other one started as well. So poking through, washer, and get the nut started here. There we go. And let me get the Allen wrench for that. We're looking at 1/8. All right. Get that on. Actually, I do not want to have to turn this by hand. So I'm going to get, since I already have my socket set out, I'm going to get the 3/8 socket to go along with it so we can do a quick change here. All right, and then if I can get the Allen wrench in on the bottom, my robot is propped up a little bit on a box, which helps me get to it. There we go. Then we can use the ratchet to get that tightened in. Looks good. Yeah. So 1/2 inch is too short, 1 inch is too long, 3/4 would be better. I think 3/4 is what we wanted for the ramp as well. Unfortunately, all we got are the 1-inchers. All right. Now that that is in like that, I can yank on these wires all I want to try to plug my battery in, and it's not going anywhere at all. All right, so let's finish this up. I'm going to plug the other battery wire here into the other spot for it, which is going to be this one. And I want this to go, I think I want this to be on top of our other wire, so we'll slide that in. Drop it down. All right, then what you can see is the reason why I didn't tighten this wire is because we thought we wanted it to go this way, but that actually ends up fighting. Our two wires end up fighting a little bit because they're not sort of the same length at that point. But if I swing it this way and bring it in towards the other wire first, now we get kind of a nice cleaner situation here. So that is the actual angle that I'm going to want to put this at. All right, before I attach that though, I'm going to undo this. I think I've decided I want to get some of the tape started on this one as well. We're close to the wall. It's not going to be the easiest to add more tape here. But yeah, so let's go ahead and get this one started. So again, I'll start kind of towards the edge of the thing. Not really covering up the flat part yet because we don't want to cover up anywhere that's going to be our actual connection. And we'll just work our way up. Okay, now we'll go ahead and drop that back on the post. We liked it in the angle where sort of they come together like this, so that feels good. And we do still have room here to be able to access all the things underneath it, so we're happy with that. And I'll kind of turn this by hand, and then, well, now I have to find where I put the actual socket down. I did it, success. Now we're going to tighten this one down the same way as the other one. So you want to make it tight. If you can turn this at all, it's not tight enough, right? So if I'm pulling right on the connector here, if I can get that to rotate, it's not tight enough. I cannot get that to rotate, so that is what we're looking for. Now, there is a good chance, I mean, there are these little, like, I don't know, these little hats that you can put on here. And these are supposed to help insulate the terminal. The problem is this. There's still all of this exposed metal that's going to be showing of the connector. So there is a really good chance that if you leave it like this, it is pretty safe, but is not going to pass inspection. So any of this bare exposed metal that is, electrically active, they're going to want you to insulate. So you might have to then take some tape and just do your best. And it might be, this might be a situation where you're going to do a bunch of little strips to just cover up anything in there that's still exposed. And obviously this is a little tricky because we're like right next to the side of sidewall of the robot here. And then I think if we try to get one more, I'm going to cut a bit ahead of time. And I'll try to like sort of fish that down into the gap in between there. And then get that, taped into place. And then maybe even reach down in here and with the tool to kind of get that pushed in, if it will. That seems pretty good. And then if it feels like, what's left over is maybe going to lift up, you could do another little bit of tape. Just like going around just to make sure it is stuck in place and not going to move. I lost the end. The end touched the bottom and got stuck. Yeah, there we go. I just wanted to wrap that around like that. And so now I don't really see any metal left on that side, so I think that's going to be okay. Unfortunately, the little hat will not sit on top anymore. So you could probably cut that off. I'm just going to leave mine there. All right, and then on the other side, we have to do the same thing. So I'll try to start with the strip that goes down through the inside. Starts covering up stuff that way. Do another one, just till I get everything covered. And then maybe one more. I'll poke it down in there with the scissors. All right, and then like if I bring this end out and twist it sort of around, that'll help seal that in place. This feels maybe like that's a spot where it could start peeling up, so I'll do one more little bit just to go around that to hold that in place. All right, that looks pretty good. And that is heading in a direction we want. Perfect. let's see. What is next? What is next to get mounted? Looks like the only thing left to get mounted is our final SparkMax. So this one is going to be for the other side motor. And we have some options. Like we could try to sneak it in this area. Because like the place it needs to go, well, it doesn't really matter, does it? Huh. The place it needs to go, we're going to have the whole intake and hopper in this area. The motor's like here, but like we can go along the basket to wherever we want to attach to it. So it really just depends on where we want to leave ourselves space. Do I want to try to package it up at the front? That leaves me a lot of room here if I need to do any connectors or if I'm going to add some other component. That's another thing to think about too, is like, hey, if you need to attach to this frame rail to be able to do your, if you're working on a climber or something like that, well then this is not a good place for the power switch. You'll have to move it. But we already talked about like it could move over to here, it could move way over to here, wherever. But I feel like just to leave the most available space for stuff, maybe shoving this in this corner is not a terrible idea. On the other hand, we do need these wires to come in and go through there. And I guess I'm going to move this. I'm going to move this to this side. That seems fine. I think I'm going to try to put it. Oh, man. Eventually, these wires are going to have to probably go up here. That's like the direction for them to run. But, you know, leaving room for some of these wires is not terrible. And I kind of don't want to cut these wires that are coming out of it. So, you know, we might be looking for a spot. Like, you know. Well, I need 1, 2 for this. So it could be in 3, it could be in 4 here. So if we put it here, where is a comfortable place for it? I don't want to put it here because that's going to block these little ports, which we care about. So I guess I'm going to put it here, just so it's also a little bit away from the Velcro where we're going to be reaching and grabbing a lot. And that seems fine. And remember, it's just Velcro down. It's just hook and loop down. So, you know, we decide that's the wrong spot. It's not a big deal to move it later. All right, let's cut a couple of strips. There's one. We want 2 the same length-ish. There's 2. Looks like it maybe has some stuff on it. Clean it off a little bit. All right. And then I said like here-ish. Push that down, squeeze it in. All right, so on these, the side with the 3 wires, red, black, and white, those are going to go towards the motor. Actually, just red and black are going towards the motor. White is only needed if you're doing a brushless motor, and we are doing brushed motors for the fuel mechanism. All of our Swerve modules are brushless motors, but the cool part about these is so these Krakens that we used have the speed controller built into the motor. That's one of the reasons why we don't have to find a million spots on this belly pan to fit all those pieces. So because they're built in, we still only have red and black wires going to the motor to power them. All right, let's see. What do we want to do? I guess let's get these plugged in. Our 2 speed controllers here, we're going to get those plugged in first. So we're looking for the red and black side. It'll be labeled V plus and V minus. And those we're going to look to plug into one of the ports. If you look on the side of this, it does have labels. So there are numbers there. and the number kind of straddles the 2 ports that you want it to be plugged into. Also, if you look on the top, you can see like where the fuse thing is. This number 18 is covering this red one and this black one. So that are the 2, right? Like these 2 would be the spots that you would need to, nope. These 2 would be the spots that you would need to plug in the wires. So it's really easy just because it alternates red, black, red, black, red, black, right? Like I could do this red and this black right here. That would not work though, right? Because one of those is on channel 16 and one is on 17. And so that would not be what you want to do. So just make sure that you get a paired set. And if you watch like as they go down here, it goes, you know, red, black, red, black. So I'm going to go into the fourth red, black. I'll leave a little space there. And that's where I'm going to plug these in. So I'm going to do 19, 18, 17. I'm going to lift up the ones for 16. And then we have to strip the ends of these wires. So whatever wire stripper you have will work. I got one of the fancy automatic ones, which, believe me, if you're stripping a ton of wires, makes a huge difference. And this is, I believe, 12 gauge wire coming off of this controller. And again, you know, we don't need to strip the full 3/4 of an inch like the last one. This is probably closer to like 3/8, maybe half an inch of wire stripping is going to be good. And there is a very large range of wire strip lengths that will work. Let me make that one just a tiny bit longer, okay? Then all you have to do is, just like before, there's a hole below. So we're going to take our wire, and you don't have to twist it up or anything, but if you have strands that are like getting separate, and it looks like they're not going to go in, you can give it a little bit of a twist just to help get it together. But you don't need to twist it up a ton. In fact, I think these connectors work better if you don't. So you're going to push that into the hole, basically as far as it'll go, lower the lever, and then you're going to pull on it. Like pull, not just like, pull on it. If it moves, you got to try again. If it doesn't move, you're in good shape. All right, we'll do the red one next to it. This is the tug test. Like yank on it. Make sure it actually is seated in there. All right, so that's good. Those wires are in. We can do the other one, which is sort of the same thing on the other side. We have our second SparkMax for our fuel mechanism. I'm going to strip those 2 wires. All right. And these ones, I think our goal was to put them, I think we wanted to leave 1, 2, which would be ports 9 and 8 for our front left swerve module. So I'm going to try to put these into 7. And we'll see how that goes. Especially working from the wrong side of the robot. All right, that wasn't too bad. All right, sort of getting a little bit of a pre-bend on it helps a little bit. Now the other wire's in the way, so that makes it even harder. But it should be somewhere. Whoop, I missed. All right. There we go. That is on its way in. Push it in, pull it down, and now with these 2, I'm going to really tug it as much as I can. They're obviously not a lot of room, but I'm pulling hard, and they're not moving. Okay, so those, and that's kind of nice. So one of the things is, like, could I have gone one more port over? Probably, but these wires would then be very tight. You never really want wires to be like stretched to their limit. Like if it's pulling way out like this to go in, that's bad for the wires and bad for the connection because it puts extra strain on it. So this is about perfect. There's a little bit of play in these wires. We have some room probably to add a zip tie or something to hold them down later, but there'll still be a little bit of slack here. So we'll be able to even take them out later if we need to. They're not jammed in super tight. All right. Those were the easy ones plugged in. Now, I think we can either work on, I guess we'll work on power from our corner modules. So let me find all the power wires, ignoring all of the CAN wires for right now, and ignoring the not motor power wires. So we're going to have 2 of these coming in from each corner. Oh man, these ones are going to be close. And then these ones from this corner we know will not reach from the front left corner. So we'll ignore those for a minute. All right, let's start with the hardest ones because they're the ones that we would do the most additional whatever for in order to get them to reach here. So I'm going to take my back left module. This is the farthest one from the back left. And I'm going to try to route these wires in to the spot. Okay, they reach. Yeah, we're good. We're good. They're just about perfect. All right, so for some reason, and I know the reason, it's that I've used these before, my black wire is a little shorter than the red wire. I'll start with the black wire. Let's strip that. This now, this wire is 10 gauge wire, not 12 gauge wire. So you got to be a little bit careful when you go to strip it. Make sure you use the slightly bigger size. And then this is also really nice wire that they have used on these. So this has more strands, you'll see. That can be a little bit more difficult when you're working with it because you don't want to lose any of the strands. But more strands make this wire super flexible in comparison. And that's really nice. So we're going to get this one right into the very first spot. So that's going to be 10 for me, but again, the number doesn't matter. But same thing, we'll just slide it right into that hole, lock it down. One of the things I'm looking for, especially on these where it has those really fine strands, did any of the strands get pushed on the side and bent out? And actually on mine it did. So I'm going to pull this out and kind of show you. Like this side here, look at that. All of that I pushed on the side instead of getting it into the actual port to make an electrical connection. So I'm going to bring that back up. And again, you can give it a little bit of a twist just to try to keep them together. But really what you're trying to do is push it straight into the spot, into the hole on the port. And that will hopefully keep the strands together. So we'll try one more time. And this time it felt like good. It felt like they all went in. So I'll lower that and yank on it. It's not going anywhere. Okay, and what we're going to want to do with these wires at some point probably is to add like some zip ties or some anchors that hold them down in place. I can see at this point that probably I wanted to leave a little bit more room next to where my canivore is, so that I had have a little bit more room to be able to anchor stuff down here. I think we can. I mean, so this is up to you. I definitely want to stay away from this this box here, which has some. I mean, I filed it, but the edges are still a little sharp. You can also put tape on that if you're worried about that rubbing on the motors. But I think we can probably like go just around over the back of the battery mount here and then go in from there. And I think that's okay for me, but if you think there's any chance you might want to work on this battery mount or stuff like that, you can always take your canivore off and just reset, peel off the bottom ones and get brand new pieces for the bottom, and you can shift that, over a little bit. In fact, even without removing stuff, there's enough like sort of space there that I could shift it over, almost enough to pass these wires through. But that feels like a little bit not connected enough. So we'll put this back on securely. All right, and then the red wire, right, like is gonna kind of join back there like that. It's gonna come through. And the question is, the red wire was a little bit longer. Do I need to cut the red wire down a little bit to have it nice? I think it's fine. I think it's close enough. So I'm just going to try stripping it and see what happens. Also, when you're stripping the wire, like I kind of did that, you don't want to strip it on top of the other electronic components because there is a chance that when you're stripping the wire, you can cut some of the strands. That's not a big deal. Like a few of the strands get cut and fall out, that's fine. But you don't want like metal wire strands, for example, to fall into the power distribution board or especially into your RoboRio. That can cause all kinds of problems. So it's better if you kind of go off to the side to strip the wire and then come back. I will be doing that a little bit, but also, to keep on camera for you, to keep in view, I'll be pushing my luck a little bit there. All right, so let's get that one pushed in, down, pull on it, that's good. And now we can have this situation where, we have room to sort of zip tie that down here. We got a nice little service loop. And then we have room to zip tie it away from our other pieces all the way back to the motor. That's perfect. That is actually the perfect length. All right, then we have our next two wires from that module. So let's see, we did the power motor, and now we're doing the steering motor from that module. So these wires are going to kind of come over. We're going to join them up with the other set so they can kind of come through here together as a little group, little bundle. And then it looks like they're going to be just about perfect length to go in there, except the black wire maybe is a hair too long. So let's go ahead and start with the red wire on this one for me, the shorter one. And I'm going to get that stripped here. And we're going right in the next port. So this will be what's labeled 11 for me. I feel like if this robot was just an inch longer, we would have so much more space around this hub. But of course, then I would probably still wish it was an inch longer. So, you know, you can't win. All right, so we're going to go this way. We're going to go this way. We're going to go that way. We're going to go this way. Yeah, I think I want to clip a little bit off the end of this wire. It's OK if you don't. Like what's going to happen is instead of them kind of coming in cleanly together, there's going to be like an extra bulge out here on the end. And that doesn't really hurt anything. It's just going to make it look a little less neat. So that's fine if you want to keep your wires as long as possible. Like again, if you're going to use these motors again in the future, that might be something you want to do. But I'm going to cut maybe about ½ an inch off of this wire. And then we'll strip it. Okay, that time I did catch a few wires when I stripped, so I think I caught those and were able to pull them away. I don't see any falling on my electrical board, so I think we're all right. Let's pass this one in and down. Tug, it's good. All right, that looks good. All right, let's do the front right ones now. And we got to really kind of figure out, you know, what is the, because these are sticking up, what is the way that we want to get these down to the frame of our robot. So this is not acceptable. You can't just run wires through the air like this. They can get caught. I mean, you can get away with it sometimes, but they can get caught. Things can hook onto them. We know our intake and stuff is going to be here anyway. So we really have to get down. Now I think I have to move where I stashed my battery connector. Trying to keep that out of our field of view here. All right, so these wires really need to kind of come down here. And maybe they come down to this standoff. We have a little standoff here that we can maybe attach to. And then if we start going like over, then yeah, I think they'll just fit. So again, they're so close, I don't want to use a connector. We're going to do our best to just make them go. The other alternative is we can come together this way and grab onto the side of this box and then come over. Now this is better for wire length. This is worse for my ability to access the bolts that are inside here if I have to do any work on the robot. You might have to snip a connector to pull the wires out of the way to work on it and then, you know, reattach them. I think what I'm going to do is either way, right? I think either way, these wires are a little bit farther away. So I'm going to take the two closer motor wires, and I'm going to go into the second port here. And then I'll go ahead and strip those wires. There's one. And there's two. OK. All right, and then let's see if we can get them plugged into these ports here that I can't see very well. I think on this one you have a better view than I do. Can I do this without blocking it with my finger? Not really. All right, so we'll push that one in, drop it down, pull on it, not going anywhere. Time for the red wire. Should be somewhere around there. Yeah, there we go. Good, push that one in. And lower it. Pull on that, that's good. And I can see as well there's no, I don't think that's a little bit of wire sticking out. Nah, I don't see any wire sticking out. So we're good. Those both passed the tug test. All right, and then our other two wires here coming in. These ones we have to strip, so I'll do that. Do that kind of off the front of the robot here, which is great. Okay, and once again, we'll lift up our spots here. And try to get the wire in. There we go. No, I closed the wrong one and pulled the wire out. All right, one more try. Also, remember, this is just stuck on by the Velcro. You could just, you know, do this. I feel like I should have thought about that earlier. Stick the wire in, good to go. Wow, this is so much easier. Why didn't I do this? And the other one, good to go. All right, and then we can line it up. We're probably going to move it again, but pop it back down. All right, now the easy one. And that is our back right module. And we have so much extra wire here. Okay, if you are comfortable making your own wires to attach in the motors, or you've got the budget to buy another set of these wires, I would cut these. So where these are going to go in, they're going to go in right here. And all of this is extra wire. And these are going to go in right here. And all of this is extra wire. I'm not going to cut mine. I want to save these so I can use them again later. So let's see. If we go kind of into a common spot here, maybe we'll zip tie it to the frame. We're going to be, I don't know where we're going to put it. Somewhere like this, but then we have to do a loop. Man, maybe I'm almost convinced that I'm gonna cut these now. All right, I changed my mind. I'm gonna cut them. It's just gonna look too messy if I don't. All right, so these wires are just gonna route along here and then plug in. Oh, they gotta do a little flippy flop, so we'll do a little twist there. And then again, when you're cutting them, right, leave yourself like a little loop here. So if I route these wires where they're going to go, down along the plastic, down around here, and into plug in, I'm not just going to be like, okay, tight, that's it, that's where I want. I'm going to go back and add like, you know, an inch, inch and a half, maybe 2 inches, and say, okay, that looks good. Now there's this little loop that's going to show up here that we can use. So I think I'm going to cut them right around there. Okay, now I'm going to check one more time just because you can't uncut them, you know? Cool. That looks good. It's kind of not true, by the way. You can sort of uncut them because we can put brand new wires on, or you can put connectors to extend the wires on. So it's not, you know, it's not the end of everything. All right, I'll get that one stripped. Get this one stripped as well. Just a little more. There we go. Perfect, perfect. All right, let's lift up. Oh, right. I left myself extra spots here. I'm going to use 17 and 18, and I'm going to leave the very end one that's easily accessible open, just in case we have other stuff to plug in later. Because these wires I know will reach these other spots. All right, plug that one in, pull on it, look for loose wire strands. Plug the red one in, tug on it, look for loose wire strands. We're good. All right, and again, we're going to have these. Well, they don't flip over. I was confused. All right, we're going to have these routing something like this. Okay, and that's pretty good. Could have maybe been just a hair shorter. Not enough that I'm going to go back and redo it, but yeah, that loop is maybe just a little excessive. The idea is it's very easy to, with that loop, to be able to unplug, take it out, and put it back in if necessary. All right, and then the other two wires are going to kind of go down, and we're going to route them along here to where they join with the other ones, and then they're going to go up with our little loop and into this spot. So somewhere around there is where we want to cut them. All right, let's strip these wires. I don't think I cut any strands that time, but I brushed against them, which made it look messy. All right, let's get that cleaned up. All right, next port over. And then let's plug these in. Tug's good, no loose strands. Next one. All right, tug's good, no loose strands. Perfect. Okay, and then the last of our motor power wires here are coming from the front. And in this case, we are going to need to extend these wires in some way. Now, these are 10 gauge wires. So some of the Wago connectors that you got, we got these Wago connectors in the KitBot kit of parts. So they basically look the same things as on the board. It's got the orange levers that you lift up and close down. These are exactly what we want for this, except not quite. So on the side, there's some labels and stuff. These are for 12 to 18 gauge wire, which means let's go ahead and strip one of these wires and see. I think we will not be able to get it to fit. So if I strip this wire here, and give it just a little bit of a twist, give it a chance, keep everything together. All right, so if I open one of these legs, what's cool about these connectors is they're clear on the back. So you can actually see where the wire is as you push it in, right? And you can see that there's, I don't know if you can see on the camera, but you'll be able to see because you have one yourself. But there is a like metal lever section right here that's going in. And then, that's not a good pointing instrument. All right. There's this metal section here, and then a little bit of more clear space in the center of it. And you need to see wires coming through the other side. And in fact, you want to have the entire bundle of wires making it through the other side in order to know that your connection is going to be, good. So if I try to push this through, it just will not go through that connector. Now, maybe I didn't strip enough wire. That is a possibility. But I think we can trust the 10 gauge doesn't really fit our wire here. It is possible to switch and use 12 gauge wire instead. Then those connectors would work. But the 10 gauge wire is kind of nice, and it's already there and connected. So instead, do I have any out? Nope. Instead, I've got more other Wago connectors. And we'll need several of these, but these ones actually go up. These are 10 to 20 gauge is what's labeled on the side. So these ones work a little different. So instead of having one connector on either side, there are two connectors both on the same side, but it does connect these two things together. Whatever two wires you put in here will get connected together. So I guess I just need one open. But now let's see if we can get this one to go in. Yeah, so that's in and through the connector. I got the insulation close to it. If I close that now and give that a tug, it's not going anywhere. So that one is in and connected. So I can do this with these Wagos. You might have to find and buy them. Now, you can also use spade connectors. I think there was a bucket of spade connectors in the kit of parts. And that is connectors that look like this. So these connectors will plug together like this. I don't like these connectors. These are absolutely not my favorites, but you basically crimp the sides down. If you can get the wires in and crimped, then they're going to be fine. I think these are probably actually for 12 gauge wire, not 10, but sometimes with these crimp connectors, you can get it to work. But these are not like quite a positive a connection. And depending on after you crimp it, a lot of times I'll have these where it's really hard to plug it in and hard to take it out, or it's too easy to plug it in and take it out, and they kind of fall apart on accident. So I don't love those. There are also another type of connector that you can use, and these are called Anderson connectors. So they have this little metal housing here, and you put the wire in on this side and crimp it down. And then you slide this whole thing into a little housing that clicks together. And then it's just these little box connectors that plug in together. These are great. It's hard to do this crimp if you don't buy the specialized crimping tool for it. So if you have access to that, that could be a good connection to use here as well. But the easiest, if you don't have any of the stuff built up, is to just buy some of these Wago connectors that are for 10 gauge wire, at least 10 gauge wire. All right, so that is going to kind of didn't plan too much ahead for that. That's going to leave us with some big connectors somewhere around here. But we did leave that room between our Rio and the side of the frame, so that's going to be pretty nice. I don't know. I guess we just won't cut any of the wires on the motor at all. So let's just go ahead. We have 3 more wires. One more for the first motor that we were working on, and then we've got 2 more for the other motor that we've got to get to. So let's just go ahead and strip that and get another one of these connectors on it. I guess I'll stick to the same side. Now the problem with these is because they're not in line, and I don't know, I think that probably Wago makes one that's in line, I'm not sure. I didn't see it, I don't have it. But because they're not in line, the next wire is going to be pointing the wrong way, right? Like this wire is routing over this way, and then the second wire is going to have to go out and loop back around. So it's not like perfect, but it's hard to beat how easy they are. And if you're getting genuine Wago brand lever locks or lever nuts like this, I have not run into any problems with them. Now there are some, if you buy the not Wago brand ones, some of them are good, some of them work fine, and some of them are less good. So just keep that in mind when you're shopping. Of course, the Wago ones are also priced to match that, so that is the unfortunate part. But still not like, not insanely expensive. I mean, we're talking about definitely not more than $1 a connector, right? So it's not like a super expensive part, but You buy a 100 pack, it adds up. All right, those are all on. We tug tested all of those, and we're good. Now we need some just plain wire to be able to route stuff out with. Now, depends on who you are working on this. If you're one of the teams that I think is getting the bundle this year, it comes with that really nice silicon 10 gauge wire. I believe you get some of that wire in it. So if so, use that. If you want to go to the store and buy 10 gauge wire, you can do that as well. I think the kit of parts has 12 gauge wire. This is not as nice a wire. It's very stiff in comparison compared to how flexible these ones are. Like these are just like, I love it. You can route them very easily. But so in the kit of parts, there is some 12 gauge wire that you can use. It is okay to connect 12 gauge wire to 10 gauge wire. But the 12 gauge wire will become your limiting factor, right? So the bigger the gauge or the bigger the diameter of the wire, the smaller the gauge number. But the bigger the wire is, the more kind of current it can pass through without melting and without having extra resistance that's going to maybe affect the amount of power that's getting there. Now, like the sim motors that we're using are going to be 12 gauge wire. They connect to 12 gauge wire, and they're going to go to a 40 amp circuit breaker. These are also going to have a 40 amp circuit breaker. So in terms of like safety or any of that stuff, in terms of the wire melting down, you're not going to have a problem with 12 gauge wire. You will get slightly improved motor performance if you use 10 gauge wire, and I mean slightly. And you can probably improve your motor performance more by shortening the length of the wire as well. So I'm going to stick with 10 gauge though, because that's what the leads are, and I like keeping it consistent like that. And I've got this lovely to work with 10 gauge wire here. Okay, and this stuff is also, guess what? Sometimes it's called zip wire, but it's bonded. So I don't know if this is what you're going to get, but these two strands are connected together, which just makes it a little bit easier when you're routing stuff. But we will have to peel apart the section to be able to strip it. All right, so let's get, I don't know, I guess we'll take the whole thing out of the bag. We got like a nice little wrap here, keeping it neat. And it will never be neat again. All right, so this, now we have to sort of like, all right, these wires, how are they actually going to route, right? And I think same thing like on the other side. We're either going to route down to this box here and end up in this spot, or we're going to go out to the standoff and then come down the outside of the robot, around the corner, and into somewhere around here. So that will affect, in some ways, like the size of the wire that we need. I think I like the idea of running the wire kind of on top of this, this SparkMax that's here. We could run it on this. I think we can run it on this beam, but I'm not 100% sure because like the ramp goes in. I think this whole top surface is clear. Actually, I mean, we built it. We can just check. So if I bring that ramp in, this is going to sit inside here like that. And you can't see it, so you'll have to take my word for it. But the back beam here is completely free. We can actually attach to this surface of it. We have a little bit of plastic down on the bottom that we can use, and we can attach to the back surface. So that is no problem. All right, so what that means then is if we're kind of routing this way out to here, somewhere around here, this is sort of where our stuff is going to be picking up and being connected. So let's do, these are the, this is the shorter wires. And with these shorter wires, it looks like we can maybe just get around. I don't want to run against the edge of this box, so I'm going to go down a little bit. But it looks like we can just get to about here with them, which means we need a wire to pick up from here, right? Make it over to a spot. This is the shortest ones, so we'll let them go into the, or the farthest ones away, we'll let them go into the closest spot. So it's going to be something like that. I just kind of like are laying the wire out as we go. Now, if you want to be as precise as possible in terms of when you're doing this, to be as unwasteful, not wasteful as possible, then you can try to cut it to the exact right length. But I often find that I make a mistake that way. So if I think it's going to be about here that I want to cut it, I'm going to cut it like here. I'm going to give myself plenty of extra because it's really easy for us to make the final cut when we line it up with the port it's actually going into. This is going to get us close to the right length, but is for sure not going to undercut it. Then if I find like when we go into it, oh, I have to route this wire a little bit differently in order to make it work, that's fine. I left myself the extra. So in this way, I'm guaranteeing that I'm going to waste a little bit of wire, but I'm also kind of guaranteeing that I won't waste the entire piece I cut because I'll be able to make it work. All right, so that, let's go ahead and, so you can peel, it just peels apart really easily. We're going to strip the two ends of this wire now. And this one feels very, okay, yep, I definitely cut a strand or two there. The insulation is very thick on this, which just means I have to be very careful with my wire strippers because I'm like right on the, I'm sort of using, it's 10 gauge, but it's 10 gauge for a certain type. So occasionally it's catching, but that looks good. All right. And then find the red one, open that up, and put the red connector in. Remember, the black wire does have some red on it, so just, you know, make sure you're getting the right one. And we'll stick that in. That is spreading out a little bit too much. I don't think it was going to fit. All right. That goes in. And we'll push it in. So it's clearing that connector. Close it. Pull. We're good. And then the black wire, same thing. Go ahead and lift the lever on the black wire. And line that up. And close it. All right. So now, basically, we're going to come around something like that, right? Because we need that extra twist in it, and then these wires can route out and go. Probably, I'm going to wait. Maybe even we push it back. Maybe we want the connectors back on this side, right? And we just leave the connectors back on that side, in which case, great, I left myself just enough room. And I'm kind of liking that idea right now. All right, let's get the other ones. So the other ones, again, if we're going to route out to the outside and down, and we're going to be somewhere around here where we want our connector to be, that means we're going to need our wire to come out from there over to, in this case, the slightly farther spot. Give myself plenty of extra to make some adjustments to how things are going. And then let's trim this one down. Okay. Pick a side, peel, and do some wire stripping. Yep, that caught one too. I think like when I look down, because how I cut it, it's a little oval shaped, so I don't know. I don't know why it catches the wire sometimes, but not others. All right. I got one that time too. All right. Again, not going to hurt anything. Okay, let's do the red one here. Pull on it, looks good. And then the black one, open that lever. I twist it up just a little bit. And in we go. Cool. That looks good. All right, now for this one, I do think we actually want to route this wire before we go ahead and plug it in, because we left ourselves so much extra to be able to deal with stuff. Okay, so let's kind of work on this corner. Maybe we'll have to move a few things here so we can see what's going on. Sort of collecting all of the tools as we go. All right. think if I go maybe around like this, we'll be able to see what we want to see. Okay. That feels slightly more secure. All right, we got to take these power wires and we got to figure out how to route them. And I have one zip tie left over from this Swerve module's previous life. All right, so these wires are going to go, I think down. I think I really like the idea of sending them down to this. There's like this little standoff right here. And I think I like the idea of bringing them down to that standoff and zip tying them on, and then bringing them over to the box here and doing a zip tie. And then maybe what we do is we take our two connectors, our connector bundles, and we leave them like here so that we have our regular wire then running off the other way. That seems pretty good. Let's go ahead and add zip ties as we go. So there's a few things that you can get to help out here. I believe the Molex box, which was in my KitBot box, had some of these zip tie anchors. So these are little squares that you can, they're adhesive and you stick them down. And after you stick them down, you can run a zip tie through either this way or this way. And then you can fold that back around and use that to hold wires in place. So that's one option that we can use. The other option we can use is because this box is all perforated, if you are able to, and it takes a little bit of skill, you can run the zip tie through the box like this as well. And so then I could take all that wire and I'm going to cut this one in a second because I don't think I actually want this one, right? But we could use that zip tie here to be able to anchor us down as well. So you can do it either way, whether you want to use the anchors or you just want to go through the box material. I'll probably do a mix depending on what we are running into to connect to stuff. So I'm going to go with these. Oh, man, we got so much stuff. All right, cool. And I like to sort of take the wires and form them up into a nice shape. So I'm going to sort of, I don't know how to keep these wires out of your way. All right, I'm going to sort of form them into a square, keeping the bottom two together and the top two together. So this is one motor together. This is one motor together. And what can help too is as you're doing this, you can start zip ties before you actually have the wires lined up and ready to go. So if I just get a zip tie started here, I still have plenty of room to adjust these wires. So then I can start to bring them in, kind of form up that shape that I wanted, leaving slack right on the tops of this. I don't want to pull it tight at the motor either. Make sure there's a little bit of an extra bit there. And then that looks pretty good. So now we can go ahead and tighten this down into the wires there. And you can squeeze this pretty tight. It will crush the housing a little bit, the insulation a little bit. That's fine. We're good with that. I'm going to trim this one. Sometimes I wait to the end to trim them all, but that was in my way, so I'm going to trim it now. And there's no, it doesn't matter. If I just take all these wires and they're all twisted up, right, and I just bundle this up in a zip tie, that's fine. It works. But the neater you can go, the easier it is to trace the wires and find out, which circuit is which and how to deal with stuff if there's a problem. So there is a benefit to trying to keep it nice and neat for future you if there's a problem. Turns out if there's no problem, it then doesn't matter. Okay. Actually flipping my connectors over so that the wires stay lined up the same way here. All right, so we have this kind of bundle here that we need to find another place to go to. And we can either do a zip tie to the side of the frame here before we come and jump down, or we could do a zip tie anchor. I feel like this one, I'm going to do an anchor. And the reason why is because we have this bracket on top. And if you ever needed to take this gusset plate off and do work to it, if I did the zip tie through the only available hole here, that would also be part of that. So there's a chance that we might not need to undo the wires when we do this if we use the zip tie anchor. So let's go ahead and do that on the inside here. I'm going to put it, I don't know, about there. Just somewhere on the inside. Okay, and since basically you want to pass the zip tie through the anchor perpendicular to the direction that you want the wires to travel, right? So you can wrap around the wires the way that they're facing. So I'm going to go down into this one. Okay, and with these, you have to be a little careful the first time you tighten them, because I just stuck it on, and again, that glue hasn't set yet. So just like we were talking about with the Velcro, that glue hasn't set, so I'm going to kind of like make sure I'm not yanking on this and peeling that off. I'm going to kind of hold the wires in and then just pull on the zip tie and the zip tie end to get it to lock in there. In the future, that anchor will set, and it'll be a lot better. If it pops off now, that's obviously you have to redo it, but if it doesn't pop off now, there's a good chance it's going to stay there for a long time. All right. And then if we take all of this that we've got, how do we want to do it? So this eventually needs to go that way. So I feel like something like this really does make a lot of sense. Keep the connectors over here out of the way, where it's sort of like easy for us to manage. And then just run bare wire or regular wire over to our power panel. So let's see, I guess if we just keep following kind of along with the other one. Maybe I do want this one popped. Back through. All right, so this area going to be a little messier. That's okay. But we'll have all of our connectors kind of coming through like this. And then we'll have the connectors on this side and then the wire running out the other way. So this is a spot where I do kind of like running through the chassis here. Holes instead. And my best advice to doing this is, like, if you try to just pass it through, it's really hard to, sometimes you can get it to hit the hole and sometimes you can't. Sometimes if you just give the end of the zip tie a little bit of a bend first, so it's curved more or bent more, then it'll be easier to find the point where you can fish it through the hole that you're going for. All right, so we can start tightening these down. And actually, at this point, before I do any more, I'm going to grab, you can use any tape that you have. Just so happens that, I have that same little bit of blue gaff tape left. But whatever tape you've got, masking tape, you could do it with electrical tape. You could do it with even duct tape. What I want to do now is I want to label kind of the stuff as we go through. So these wires are going to enter a bundle like this, and coming out the other end, it's not going to necessarily be obvious which wire is which. Now, because I'm going to take my time and I'm going to try to make this bundle be as clean as possible, we probably can trace the wires back, but it's going to be easier if we don't have to. So if we go to the module here, what you can do to find out which motor is which is if you roll the wheel. So if you kind of have this up off the ground, if you roll the wheel, you can see one set of gears is spinning, which will make one of the motors spin. So if you look in to find the motor pinions, one of them is going to spin when you roll the wheel. All right, so we know now this is the power one, right? That's the one that moves when the wheel is rotating. And this one is the steering one. That's the one that moves when you rotate the wheel. So we can kind of do a couple labels on here. Now this middle section, there's like a clear section in between Talon FX and CTR Electronics. that is LEDs to see what's going on. So we don't really want to cover this up. Probably I'll end up putting my label on the side so that it is not blocking that. But let me mark it on the top, and then I'll move the tape over because I can't write sideways. So this one is left side of the robot, front of the robot, and is the drive motor. So this is left, front, drive. Okay, and then we can take that, and I'm going to stick it down here for now. Cool. And then the other one, this is going to be left, front, and this is our steering motor. So this will be LFS. Okay, and then we can stick that on the side. So that's labeled. All right, then if I go back, we go back through and we follow the wires, right? These two wires coming to our longer two connectors here, coming out to this set of wires here. This is my steering ones, I believe. So I'm just going to kind of do a little fold it over on there, make a little tag. And let me just verify that one more time. Definitely do not want to get this mixed up. This is steer, yep. So this is going to be labeled as, so LF and then S, left front steer, cool. And then that means the other one coming out of here, we'll get another little tag for it. This one is going to be left front drive. Okay, and I might go through and label some of the other ones, especially as we go to zip tie them down. But like right now, it's really easy for me to pull these apart and see which wire is which. So until we're actually anchoring them, I probably don't need to get the labels on. But like once they're zip tied together in a bundle again, it's going to be really nice to know, like, okay, this is, you know, that, this is that. Cool. So now back to what we were doing, getting this bundle as nicely oriented as we can here. It's kind of like those going in and these two coming out. We just got to kind of turn that into a neat stack of wires. Then we can pull this zip tie in and tighten it down. All right, and I'm pretty happy with that because I can get into this channel to work on stuff if I need to. The wires are bundled up nicely. They're inside the frame, not going to get hit by anything. And now we've got our two long runs here of just wire. That's going to make it all the way nicely to where we're going to jump in and attach to our power distribution location. So I'm going to turn this back around a little bit. What? Oh. It was on the tape. I was like, it wasn't sitting flat. Why isn't this sitting flat? All right. Next up, let's finish getting these power wires here plugged in to their spots. So this first left front drive one, right? Like we can run right along this edge here. That's perfect. And then we're going to just do a little twist over and go right into that front port. Looks like, you know how I was like, hey, let's make this wire just a little bit too long? Mine is now exactly the right length. So should have done a better job measuring and estimating, but that's why I always do that extra chunk of stuff. Of course, if it's too short, just get a new wire, try again. We're not using that much wire, so you should be all right to... Oh, that got a couple of them. I think maybe going slowly is not the answer. I was trying to go like slow and careful, and that maybe makes it worse. All right, and once again, just for everybody's ability to see what's going on, I'm going to pop that up. Lift up the first two ports here. So this is going to be routed this way. but then we're going to have to do a little flip over. That's fine. We can do that. So we'll go with the, ooh, is that a loose? No. Just got untwisted. All right, so those go in. Close it down. And then the red one. Close it down. And you can see, yeah, that's going to be, man, that's like perfect. The I did too much was actually exactly correct. Okay. Then this wire is going to continue to the next port, and it's going to have to do the little flip around as well. So we're going to be somewhere around here. Okay, so I'll cut it about here. And this label, I thought I was going to have to completely remove the label because I thought I was going to cut a lot of extra wire off. But then I changed the way that I wanted to route it there. Of course, if you want to route yours differently, that's fine. But now this is sort of like just in the way. So I'm going to remove that and make a new one. Just a little bit too close to the front. Okay. So we need this peeled back to about, I don't know, somewhere around there. So something like this seems good. And this is, so the other one is left front drive, so this is going to be left front steering. I'm not going to get carried away, but it is maybe not a terrible idea to label on the other side too, because then if something happens and it gets rubbed off on one side, you still have a backup spot, but that's, you know, not necessary. All right, let's open our next two spots. And once again, let the red wire go in, and then the black wire goes in. I think I can push that back down. And that, yeah, that looks good. That's what we want. Okay, we might as well finish routing this wire since we already started it. So I'll get some zip ties here. And I'll probably grab it like in this next spot right after the channel. Oops. Got to make sure the zip tie is going through the right direction. This will make sure it doesn't get loose near the channel where maybe we have some sharper edges, or at least the end of the channel is there where it was cut. So this will help hold it in place there. And then we can route along to wherever you feel like putting another one. Somewhere in this neighborhood seems good. And then I'll do one more just over in this area just before they start twisting over. We can wrap that label on a little tighter. Perfect. Right there. All right, that is pretty nice. We can go ahead and clip these, staying out of the way of everything else, and definitely secured. All right, let's go ahead and route our other power wires the same way. Get some zip tie anchors down and probably get the labels on next. So we can jump to back left. Kind of had some plans for that. Now, I have the bag of zip tie anchors. I think you got them too in the kit. So they're nice to use because they're easy, but you know, at any point, if you're like, okay, I want these wires bundled together right here, you could also, you know, kind of mark it, drill a hole, mark it, drill another hole, and then you can run the zip tie around that. I'm going to try to not do that again, just because I really want the bottom of this to be free of obstructions because of that bump in the middle that you can drive over. But also, you know, the zip tie anchors are a little bit easier. You know, getting the second tool out, the drill out, and drilling all the time is going to be messier and take a little bit more effort. So in that regard, I also like the anchors. All right, so let's see. What can we do with this section of wires here? So at some point, we're going to have these wires join each other, come together, and then they can come through here together. Something like that. Okay, that looks pretty all right. Looks like my red wire is just a little long there, but that's fine. That's fine. That's fine. Okay, so somewhere around here seems to be like where I want my last anchor to go. That seems to give us space for the wires to be able to plug in. So somewhere around like there, say. And we can get the zip tie started. Just make sure the wires are in the zip tie before you start it. And then we can try to get them organized before we pull it down tight. And that feels pretty clean through here. Actually, before I do that, let's go ahead and do the labels because it's about to get harder to see them. All right, so now we got to check again. Okay, because this is an inverted module, so I can't try to like mentally figure out which is which. All right, so if we lift this up, well, I can look at it and tell. But if I roll the wheel, make sure your wires aren't in there. But if we roll the wheel, this one's spinning. That's our power motor. That's our drive motor. If I rotate the wheel, this one is spinning. Sometimes when you rotate the wheel, by the way, both might spin, but one of them is going to spin more. And so this is our steering wheel. Spinning the wheel, rotating the wheel in place is going to definitely just make one move. But when you steer the wheel, sometimes both of them can move. That's just the nature of how the bevel gears work. All right, so once again, I already forgot. This is drive. So let's get those wires over here. That's these two. Is going to be our drive motors. They will kind of, where those are going to end up. Try not to affect it too much. Sometimes with these two, if you think you were going to want to take these off, you can like tuck it over and get a little tag to be able to unpeel it. But I'm just gonna sink it on there. All right, so this one is drive. So this is left side, back, drive. So this is going to be left. I'll do L. I'm going to do back or rear. Left, front, left, back. I like back. I'm going to do LB. D for left back drive. And then one more tag on this one. That's huge. I don't have the best penmanship, but even I don't need that much space to write. Now this one's a little short, so I'm going to probably eat those words. All right, this is left, back, steer. Okay, and then just so we don't always have to do the whole let's spin which motor and figure out which is which, I'm going to also get myself a tag that is, this is probably big enough for both. Let's do that. All right, so this is going to be left, back, drive. And this one is going to be left back steer. This one is the steering motor. And this one is the drive motor. Cool. Now we can go back to the zip tie that I almost had all set up before I realized we should label it first. So that feels pretty good. Well, that's weird. And just broke off my zip tie there. All right, well, you know, here we go. Again, I'm feeling, just to make sure there's some play here, that it's loose, that I'm not pulling anything too tight. Cool. That one's good. All right. And now I think I want to get another one like right here by the corner so that I can make sure it's not running into the corner of this battery bracket. So we'll sneak one right about, oh no, I went on top of one of the wires. All right, there we go. And then let's get a zip tie started. Which way is easier? Maybe. I'll try to go the other way. The other way is hard to get it started, but will be easier to lift the end up afterwards. That was definitely easier. All right. Okay, and then I'll try to get that neat bundle shape in there as well. So to make sure that that stays away from sharp edges and moving parts. That is beautiful. Okay, and I want this one wire to have just a little more slack, so I yanked on it and tugged it through a little bit, and that's fine. That got the job done. Okay, and then at this point, you know, these wires are pretty good and they're laying flat, but I do kind of go overboard sometimes on wiring. You probably could stop now, but I do like the idea of having one more anchor for these wires here, and then one more anchor for these wires somewhere like here-ish. Of course, this one is going to be very hard to get the zip tie through and up without going underneath the RoboRio here. I'm going to really twist up the end and see if I can get it to scoop around the corner. No, all right, plan B is to just get a screwdriver to lift it up. Which works. And so pull this one in and tight. One more for this one. Looks good. And trim those ends. And we will move on to the next corner. All right, let's do right back. Some plastic on there. All right. Right back. I guess we might as well get our labels going first. All right, so let's figure out which one's which. If I lift it up and spin, this is our drive one, so this is drive here. Does that make sense? Yes, if you rotated this around to the other side, that would make sense. And then the steering wheel is this one. All right, so this is our drive. Let's get these labeled. So this is right. I said the word right, and I wrote a B. I'm not really sure why. All right, right, back, and then drive. And that was, once more, this one. I got distracted by my inability to write letters. Okay, that's right, back, drive. Which means, by process of elimination, we should have right, back, steering on this one right here. Okay, and then, I think they make specific like wire labels that you could definitely use instead of tape. I don't have any, so I'm gonna keep going with the tape. The tape works fine. I think you could also get one of those label makers. Sometimes the labels, like, you got to make sure you can wrap it around the wires and stick it to itself, because especially these wires, the silicone ones, things do not like to stick to them, so just keep that in mind. All right, this is right, back, drive, and then just a little bit. Oh, well, now that's probably too small. Well, so it goes. All right. And this is right, back, and steering. And really, in this case, like, it's obvious that they're both right back, so it's really just knowing the drive and the steering is the most important parts for us. All right, so if these come together somewhere, we can do one little spot where they both get attached, and then we can do a spot where they can each get anchored for the motor themselves. So it feels like I kind of want to keep them back away from these little ports here, so that's where I'm going to aim my little zip tie anchor. So I'm going to go with this one basically right back by the corner here. Okay, this zip tie, is that it's not clicking, but it seems like it's getting tight. We'll see. We'll see what happens. All right, so we'll leave a little bit of room there. Yeah, okay, that worked. I think these pieces are moving in towards the metal here. The ones we just did are fine. The other one maybe is going to be a thing. So we'll look at that in a second. All right, and then I want one anchor over here for these ones. And then one anchor over here for these ones. Seems good. That time the little bend did, well, yes, did get it to go. Yeah, it did get it to twist around. I gotta make sure the wires get back to the inside. Seems good. All right, now for these wires, again, it looks like, to me, these wires for mine are getting close to this edge. I probably should have filed these corners a little more. You can do a few things. Can get a piece of tape kind of on there, which means if the wires do end up rubbing on it, well, now it's not, you know, the metal. That's the end that's there. The other thing I could do to help out a little bit is I could take these wires and I could bundle them to the wires next to it. So like if I attach to these wires here, probably like in this orientation maybe. Now, right, they won't be able to move over as far, it doesn't look like. I can still bend them over to touch, but like there's nothing that should let it drift that way. So I think that, you know, helps a little bit too. Okay. One more module set of power. By the way, the other one, this wire for the our other intake or launcher wheel, that wire is already cradled underneath. It can't really move at all. You could maybe try to get a zip tie in there, but I'm actually going to not bother. I think it's totally fine. So now we're on this module up here, which means I gotta move my battery wire out of the way again. All right, and let's see. So we tried not to cut these ones. So we're gonna be a little bit length limited. We might not be able to run it quite as nicely as we did on the other side. So that's what we're gonna check in for. So let's just get a feel for what we got going on here. Like, can we go to the same standoff or not is really the question. And it looks like, man, we're just a little bit short. It's just a little bit unpleasant to go out there. So I really liked going along the frame rail on the other side. It does not look like we're going to be afforded that luxury on this side. And we're basically choosing which bad thing we want to have happen. Well, not bad, but which less good thing we want to have happen. We can either run the wires the way we want, needing them to be longer and forcing us to use a connector, or we can jump through the gap to get the wires a little bit straighter and have the wires less secure. For me, especially knowing this area is pretty protected. It's inside the robot. It's right next to the big intake. I think I would probably do a little shortcut on the wire route than to add a connector, because the connector is another point of failure. So you can make that decision for yourself, but now let's see what we can do here. I'm going to work backwards, I guess, in this case. So when these wires come in to the final spot, I definitely want to get an anchor, right, like somewhere around here that's going to hold it down, again, away from the edge of the channel that we cut. And I said anchor, but I just mean like that time I meant it as the regular word anchor, not as a zip tie anchor. All right, so if we're something like that, there's a little bit of slack here. I think I could unplug those if I had to. Of course, worst case scenario, you cut the zip tie and then do it and then put the zip tie back in. So it's not, you know, it ain't crazy. All right, then how much do we have left? right? Like over in this area to do something. So I think what we're looking at is, I think we can get one more sturdy attachment point there on this beam right behind where you can't see. And then I think we can just run over to the cage. Not quite over to the standoff, but to the cage here. So we'll come around a little bit for this step. Okay, and got all these other wires in the way, which is always making it a little harder to see what's going on. But so what I'm thinking is, if we take these and we basically go as straight down as we can, but I'm going to attach to, there's a little hole right here on the cage that I can use, or you can go through the open webbing part. I'm going to go through the hole. I'm not really sure why, but the zip tie fits, so I'm going to do that. If your zip tie doesn't fit, just go right next to it. And this feels like, oh, I've changed my mind. It's getting stuck. I'm going through the webbing that's right next to it. Okay, and if we bring these in here, kind of, to a nice bundle. The one thing I'm doing is I'm making sure I'm not over pulling on any of the connectors at the top. Like there's still a little bit on all of these points where they plug into the motor. Then we'll go ahead and zip tie that down. That kind of do some strain relief for the motor. And then down here, right, it looks like more or less, I want it to sort of follow this path. So it gets over, and then we can get around this corner. So I guess the first one is, this might be a zip tie anchor situation. If you put a zip tie anchor here, then we can change directions like that. Again, if you're good and you have some practice and you do a little twist on the end, so I'm kind of like rolling the end up, you get a little kind of like a hook shape. And you can actually go down through one hole. Which ones do I want it to be between? You can actually go down through one hole and sometimes get it to pop up through the one next to it. Is that worth saving a zip tie anchor for? I'm not sure. But I've spent a lot of time zip tie fishing, so okay. We really want these to kind of be making a turn there. So that also is going to help us keep it away from the channel edge, and just a little tighter. Perfect. Okay, and then the last thing I'm going to do on this side, oh no, we didn't label these. So now we're going to have to trace the wires while they're all bundled up. Should have labeled them before. You can always cut yours if you can't tell which one's which, but let's go ahead and see if I can trace them. And I did keep like a nice shape in my connector, right? So I can really easily see these wires are here, these wires are here. Which means these wires are on top, which means they are the ones going farther in. So let's go ahead and get everything figured out what's what. So we get a couple of the labels here. If I spin the wheel, it is this motor. Again, the outside front motor is the one that's spinning. Does that make sense? Yeah, sort of, yes, it makes sense. Because these are mirrored of each other, not rotated. And that means, all right, so this is right. We have right, front, drive, and right, front, steer. So one more time, this is the drive one. This is the steer one. I'm going to put this on the side that you can't see, but I promise it's there. All right, and then we can go ahead and label the wires here at the end. So this one is steer. I can see the wires visually all the way to where we're going. So that makes the label a little bit less necessary, but you never know. Like when you're at competition and you're rushing to figure something out, like it's easy to make mistakes. So anything like this that makes your life easier is probably worth the couple seconds. All right, so this one is going to be right front steer. And the other one, actually going to write this one before I tape it on, is going to be right front drive. All right, and my problem with this one is actually that, like, all right, I lose. I'm going to clip this one zip tie. I can't get to it to wrap the tape on because it's just a little too snug there. All right, now our label's on. And I'll just redo that zip tie. Good. The last thing I'm going to do before I realized I forgot labels and then went back and did the labels is this bundle of wires here still can kind of spread out from each other. So we can do one more thing that just can help strength-wise. And that is just going to zip tie them together to keep them as a full bundle through this area here. This is the area I don't like because we're sort of flying through space. But it's not too bad. It is inside of the robot. That is a place that, you know, in theory, another robot, if it reaches inside, could hook. Now that's, I think, against the rules. So, you know, I'm fairly confident with this. This is also a bunch of bulky wires. You could do also, if you were really worried, you could do a second zip tie anchor up here. So now if it grabs those wires, it either has to rip the wire itself, right? Or it has to break both of these zip ties up here and then rip it out of the motor. Or it has to break both of these zip tie anchors and rip it out of the power distribution hub. So it's probably pretty safe. All right, that is all of our motor power wires routed and plugged in. I think I've reached the point where I have so many cut zip ties and wire stripped ends and whatnot that it's going to make sense for me to clean up, get a little organized, and then we'll come back and do power for our cross-the-road devices, our RoboRio, and then also do our CAN wires. All right, now we've got to get, like I said, we have power from, I guess every Swerve module, first of all, has 3 different devices. We have the 2 motors that need a CAN connection. We've got the CAN coder, which needs a CAN connection, and then each CAN coder also needs power. So we got to find a way to get all those powers connected as well. And then on the main board, right, we have our Pigeon and our Canivore that still need to get hooked up to main power and into the CAN loop. So the way the CAN works, or the wiring for CAN is going to work, is basically every device has to connect to another device. We're going to make a chain. The idea is not to have like one device that connects to 4 different devices. They're all going to have one connected on one side and another device connected on the other side. And the end of that chain, or the beginning of that chain, is going to be our Canivore. That's going to be where we start the chain. So this is like, I don't know, whatever, position 0 on our CAN network chain. And then it's going to connect, by the way, I said 0, but the order that you plug stuff in has nothing to do with the IDs later when you program. So just keep that in mind. That's completely separate. Devices can be labeled however you want after the fact. All right, so from the Canivore, we need 1 set of CAN wires going off to one of our modules. And it looks like, remember, your wires are all going to be like long with this connector on the end. That's fine. We're going to do a lot of cutting and a lot of stripping, or actually there will be a lot of that no matter what. And then if you want to use these connectors, I'll show you how to use those connectors. But the idea here is if we take one of our wires, it should be long enough to reach over to CAN low and high on the canivore and plug that in. So now we've gone from the canivore to the first motor. Then that motor, we're going to do the same thing in every module. So we'll kind of do one module and then fast forward a little bit. But every module is going to have one wire from the first motor that connects to our CAN coder. The other wire from the CAN coder is going to connect to our other motor. And then that other motor's second wire is going to go out to the next module. Then that module gets wired the same way. Motor in, the motor that came in with the signal is going to feed over to the CAN coder, which is going to feed to the other motor, which is going to feed out. Now that out motor, I think between the two fronts, we'll probably get our pigeon attached because that's in between there. So we'll probably route through the pigeon to the other one. Same thing here, motor in, CAN coder, motor out to the next module, motor in, CAN coder to the motor out. And that motor out is a little bit special. That last motor out has nowhere else to go. There's nothing else left to connect. And so we need something at the end of that motor, which would be, I don't know, this set of wires maybe. We need something at the end of this set of wires that says, OK, that is the end of our chain, of our wire. That's the end of our CAN network. And that thing is going to be a 120 ohm resistor. So we're going to have a little 120 ohm resistor connected there. All right, for all of the things that we're connecting, once again, any of the connection types will work. So, you know, whatever we have, some of them will have the ends. There we go. We would have these ends coming out. And it is fine. This is a connection. This is an electrical connection. As long as you get the green wire to the green wire and the yellow wire to the yellow wire, that would be one way to connect stuff. Now, this maybe is not the best way because there's no locking feature on this. So you can add some tape and stuff like that. That helps. And it's probably OK if you're careful and strain relieved, but is not like securely locked together. So that's one option. The other problem with that is look at all this extra wire to go from this motor to this motor. I mean, like, so now I got to bundle all of this up every time and find a place to put it. So if we cut it, that's fine. You can solder the wires together. You can use any of the connectors we've talked about before. I'm going to be using a series of different Wago connectors. So one of them that I'm going to use looks like this. And I believe this was sourced from West Coast Products. So a lot of you might have this in your kit that you're getting if you're one of those teams. This is cool because it has green and yellow on it. The green wire comes in and green wire goes out the other side. Yellow wire comes in on one side and another yellow wire goes out the other side. So because this is sort of like two of these side by side and color coded, it makes it kind of nice for the CAN wires. I'm going to use as many of those as I have, but if I run out, it's OK. There are other types that you can use. So we can just use you know, a little one like this, where you can run two wires in and come out the other side. I believe these ones, which came in the KitBot crate, are rated for 20 gauge wire. Let me double check that. So these are 12 to 18 gauge wire, it looks like. So we'll do a test, and I can do that. Well, let's do it right now. If I just grab one of my already been used pre-stripped wire ends here and kind of clean it up. If I put this in to this connector and close it, because I don't know if this is 18 gauge wire or 20 gauge wire or what, but if I put it in and close it and I pull, that one can just barely come out if I pull very, very hard. So it looks like if you're careful, well, I'm going to have to, let me snip that end too because I ripped some wires out when I did that. Actually, ripping wires out means it might still be fine. Hold on, hold on. If the wire's ripped, then the connector might be fine, right? It's if it slips out unimpeded that it's a problem. So this time I'll be a little more circumspect with it. You know what? I would be comfortable using this. I think these connectors will work fine on the CAN wires as well. So if you don't have the other ones, but you got the KitBot stuff and you've got a bunch of these connectors left over, it is totally fine to try to use these on the CAN wires. And then I think this other style Wago does go up to 24 gauge wire. So if you did need to get another one, you could get one that gauged down a little bit smaller. And you might find some that are like this. These are, I think, not Wago branded connectors. Just trying to read the writing on the side, and it's a lot harder to read. So some of the connectors like this will also work. What I'll say is, if it is a Wago branded one, I've never had a problem with them. The Wago branded ones seem like pretty rock solid from my experience. There are a lot of connectors that look similar, but are not like Wago. And your mileage may vary with those. Some of them are great. Like I think these, the ones that we have here from West Coast Products, I think is who I got these from. I can't remember. These ones have not caused me any problems, and I've used them for the entire other series on Swerve and quite a bit with testing. So I'm confident that these are fine. But like, for example, if you went out to a random Amazon or eBay and looked for connectors that look similar and picked a random generic brand, I'm not sure if that one's going to be good or not. So just be careful with unvetted versions. All right, let's go ahead and start working with, we'll start working with this module here. So this module is cool because I have 3 of the wires were not cut yet. So we can kind of give you the full experience of what stuff is going to look like to wire up one of these modules. So first thing on, and you can do this too, on the front left, front right module. I rotated the robot. Front right module is where I'm going to start. We have 4 wires coming out of the motor. Right off the bat, we can take 2 of those wires, doesn't matter which 2, 1 from each motor, and we're just going to kind of ignore those. Does it matter which one is which? It does not at this point. Okay, so we're going to just take 2 of those, and I'm going to just put them out of the way for now. Now the other 2 wires coming out, we're going to end up cutting and stripping those wires, and we're going to be looking for our 2 CAN coder wires as well that are coming out. And those I think they come with the wires just not stripped. I don't think there's a connector on them. Let me look at my one untouched one. Nope, it does have connectors. So you will have this same style connector on the end of your CAN coder wires. Mine all, again, got cut in the last series, so I can't redo that, which you can watch that series as well for a slightly different take on how to wire stuff up. So if you wanted to, if you were just going to use the untouched ends, what you can do is you can take one of the connectors, plug it into the CAN coder, right? We would have a connector there, so these 2 could plug together. The other wire from the CAN coder, you could then plug into one from the other motor. And this is what we talked about. Now you have these long loops of stuff that you have to deal with. But that is one way to connect it. Instead, right, I have my 2 separate wires that I'm just got off on the side that I'm saving. Those are my outs. One of them is going to go out to the other front module. One of them is go to the back module on this side of the robot. Okay, and then we're going to kind of look at like how do we want to kind of route stuff here? Like where do we want these wires to live? And it seems like on this one, our best bet is to really just take all of our wires that are going to leave and route them out along the power wires that we have there. But our internal wires, so the set of wires that aren't going to leave, we've got 4 yellow and green wires that aren't going to leave. And they all need to get connected together. So we could probably go down through instead these wires to get them all close together. And then same thing with this one. And our goal here is going to be essentially to have some connectors somewhere where we can connect stuff together. And I think, wow. I think you've got a lot of options. I think probably what I would do with these is I'll still take the connectors down and kind of connect the connectors in the same area over here. You do have the option of going around to the front edge where there's a little bit more plate here. So I could take all of these wires and feed them through to this side. And that's really appealing for a lot of reasons, because there's this sort of like space on this front plate where we could connect them. But I'm a little worried because that's like the front of the robot. That's what's going to drive into smash stuff. I guess it is a swerve drive robot, so we move in every direction. So that changes it a little bit. But I think I still want to just kind of come out in this direction. And I guess we could pop over to the inside here. I don't know. It doesn't really make a difference. But if we take all of these wires through, Yeah, I'm going to put them on the inside just so they're a little bit more protected. There we go. All right. And then these two again, these two are the ones we're saving. They're going somewhere else. Tuck those in a little bit. All right, there we go. Now, okay, I have the motor from this, or the wire from this motor. And that is going to connect to one of the CAN coder wires. So this is the other motor wire. And it doesn't matter which CAN coder wire. They're both going to be the same. So I want to connect these two together and then have some room to be able to kind of bring these down a little bit so the connectors can kind of live in this area. So, I guess we'll do a little bit more trimming. This one for me looks like it's cut about as far as I would want it to be cut. I'll just make both of those even, pretend like I just cut it to this length. And this length is about long enough to get down, to the bottom of the Swerve module plate, a little below the bottom of the Swerve module plate. You might leave yours just a hair longer. Okay, then the CAN coder wire. I'm going to go ahead and cut it down so it's going to reach out. We're going to go down this wire, and we got to like connect back into the one that's there. So, going to kind of make them about the same length. This is just going to, depends on how you're going to bundle the stuff up. All right, and then we have these 4 wires. One set from the motor, one set from the CAN coder. Strip all of the wires. And again, we think these are 18 gauge because they worked in the 18 gauge Wago. And they strip with 18 gauge, the 18 gauge spot on my wire strippers, so I'm believing it. So we'll strip all 4 of these. All right, and then I'm going to get one of these double connectors and lift it up, lift it up. Just always make sure that green and green connect together and yellow connect together. That's going to be the first troubleshooting step on this robot if it doesn't work, is make sure you haven't flipped your CAN wires anywhere. Green and green, yellow and yellow, locked in. Again, give it a tug. Obviously, these ones we found out if you pull really hard, you can break the wires, so calibrate your tug accordingly. And we'll feed the green one in there. That's good. Yellow, that's good. All right, so this is one bundle that we're going to probably put down here somewhere and just, lock that in. Use the main power motors for some support. All right, then we have the other 2. So this is the other CAN coder wire and the other motor wire. Okay, my other motor is brand new. It's got the connector, so that's what we're going to be looking to cut. So the CAN coder, we want to go out and then loop around a little bit. So we're looking at cutting it around here. So I'm just kind of like routing that out down along the wire and then having enough room to loop back. So I'll cut it right about there. And then my motor wire, this one can be a little shorter, but I don't want to pull this one straight out. I want to leave myself room to come down along the motor and then travel out with the CAN coder wires. So I'm going to be somewhere around here, following that routing, then basically to end up where this connector would have ended up-ish. So somewhere around here. If it's a little long, that's okay. We can always zip tie it up into place. And if you want to, again, save these wires for use later and leave them as long as possible or preserve the connectors that are on them, that makes some sense sometimes, in which case, you're just going to be bundling up a bunch of wire at the end. That's fine. All right, let's go ahead and strip all the wires. 2. 3. 4. And this time, Let's pretend I don't have the yellow and green connectors. So if you're a team that doesn't get those, let's go ahead and just use these ones that were from our KitBot crate. Sure, all the wires get in. There's one that's trying to run away from me there. All right. Slide that in, lock it down, a little tug. Make sure the green one goes. Yep. And that's something you got to watch out for. When you put it in, make sure none of the wires are bent back, especially on these smaller wires. You want to make sure all the wires are reaching in and getting there. That time I bent a few back, and knowing that that definitely makes it a little weaker, right? I want to make sure they're all clearing in. So we got green to green on that one. This one we're going to do yellow to yellow. And that's why I love these Wagos, because they're completely clear on the bottom, and you can really easily see, the wire going in. And if you get it bent up or anything like that, give it a couple tugs. That one looks good. Okay, so we're looking at kind of like this situation with our wires here that we can bundle up. That's perfect. Okay, and then let's actually route our wires out. Now, you can use whatever zip ties you have. I think with the little zip tie anchors, there was a bag of tiny zip ties. So sometimes with tiny wires, tiny zip ties is a good way to go. And like I said, I wanted to do one, kind of in a hard to see spot here, but I want to do one where this wire here, I kind of want to bring it down and have everybody traveling together. And then same thing with the wire that's going out. I'm going to route that the same way at this point, because these are going to go out, but we still want to get some strain relief and stuff like that on them. So this one is also going to run the same way now. So we're going to join our other two CAN wires from each of our motors into this bundle that's going out. And in fact, also the power wire. So all of this is now going to ride along the wires that we already did to get into the robot, and then we'll kind of stop there because we don't know where they're going after that. And those red and black wires are a little short, yours aren't cut though, so you should have a little bit more length on yours, I hope. Okay, but these two here that are coming down, I'm going to bring these down, and I'm going to pass the power wire, I guess, through here as well. Oh, maybe not actually. This might be it for the power wire, because that looks like factory edges for me. I'm going to basically take all of these wires and bundle them up together down here, right kind of where they're coming in out of the CAN coder. And that's just going to be like a little bit of strain relief, a little bit of like, don't let the wire travel through space where other things could maybe catch on to it. Okay, and then I'm going to focus on the 3 wires that are leaving first. And those ones I want to kind of have sitting on the bottom. And then these ones can come down and just be a bundle wherever they're going to be a bundle. All right, so go ahead and attach these. Now we do have 2 different wires coming out here. And they're going to be exiting at exactly the same spot. And you might be like, uh-oh, which one is which? Well, it turns out it doesn't matter for CAN. If I have this wire going this way and this wire going this way, that's going to work. And if I flip them over and have them going this direction, it's also going to work. So you can label them if you just want to know which wire it is. Like if you have to, like, oh, we think this wire's bad. But at that point, you're cutting all the zip ties anyway to get to all the wires. And so it doesn't really matter. Like I said, it's going to work no matter which one is where. So I'm not going to worry about that too much. Now, I am going to take the red wire. It's probably going to need some kind of a connector. We'll see. I'm going to kind of leave the red wire free. I want everybody to kind of be free. So it looks like I'm going to do my last zip tie right now. Right here next to the other zip tie, right at the start of the box. Something like that. Okay, and these bundle of connectors, I don't want them flopping around. So I'm for sure going to do at least one more zip tie to kind of hold them in. And I'm going to try to, like keep them in against the wires, but keep them to the inside. Again, it's just all about keeping your wires out of trouble. And we'll go ahead and zip right onto that bundle of connectors. And that looks good. Clip all of those. All right. So we should have 3 wires coming out of the front there. Now, on the other side front here, so that was our right front. On the left front, we're going to basically do exactly the same thing. So we have a little bit different shape of wires down here that the bundle's going to ride through. But for the most part, I'm going to take all of my CAN wires, get them kind of through to the inside of the power motor, or the power wires like this. And then we're going to repeat the process. So we're going to have 2 wires going out, long wires, uncut wires going out, whatever that is, 1 from each motor. So, yep. So these ones are my out ones. This one's very short for me. So yours will, of course, be different, but leave 1 long one going out this way, 1 long one out ready to go the other way. Get your power wire going out. And then we're going to have, once again, the CAN coder wires are going to connect to 1 motor on one side and the other motor on the other side. So you can do those joints the same way we did them on our first Swerve module. All right, so I did the same thing, right? Like motor to CAN coder to other motor, and then we have 2 motor wires coming out and the power wire coming out. Now, one of my motor CAN wires coming out is brand new and untouched. The other one is really short. Yours should be longer than this. Your life is going to be way better than mine with your wire being a little bit longer. But I am out of wires to swap in, so I'm going to have to make this one work. All right, and then we'll save these. Let's do one of the inverted modules. And basically, we're going to do the 2 inverted modules the same way. So you can be doing both of those at the same time if you got 2 people. But I'll go ahead and flip this around so we can see the inside of the inverted modules here. And I'll grab this one. Now this one, with the inverted modules, it's a little bit different. It's actually nicer, right? Because all the wires for the motors are already down on the bottom, ready to leave. So our out wires, I'm going to keep my 2 long wires as my out wires. Yours should just be completely uncut at this point. Those can just head out in the directions that they're going to go. And then I've got 2 short ones. Go ahead and you can clip yours and cut yours short. But I think what works really good here is if we come with the CAN coder, right, and do this on this corner and the corner over there. Get both these corners going. We'll go ahead and come out to the end of this plate and then come down. Looks like we can, maybe that's a little scary place to put a zip tie. Looks like you could get a zip tie here in the middle. That's going to be away from the moving gears. Just make sure, yeah, I think even if it's tight, it'll be okay. Make sure that you tighten that in the middle of the space, again, so that it does not get anywhere near the gears here. Okay, and then we'll run these wires down to this bottom standoff, down here underneath everything. And that will be a great spot for us to go ahead and connect stuff together. So this is, again, I know we needed the non-inverted modules in order to fit the intake, but this is one of the nice parts about the inverted modules, is the wiring comes together a little bit cleaner for us. And everything is just lower down and a little bit more protected. Okay, so I have wires from the motors that are going to come in, and we can either, we got a little bit of a gap that we're going to have to run across here, but we can either bring our motor wires in to do the connector, or bring our CAN coder wires out to do a connector. I wonder if how do we want to do it? So one thing is, I don't want to get too much shorter than this on the wires coming out of my motor, just because it doesn't give you much space to add loops or anything like that, and at some point it gets too short to do anything with, but I'll clip mine just a little bit shorter. I think my goal is going to be to take one of these connectors and be like here and here with this one, and I'm going to come down sort of to the power wires that are in this neighborhood. So I can trim this one just a little bit shorter and make that work. So we'll come down kind of in this area here with it. And then on the other side, I think if we route these wires out together, then we'd be somewhere in this neighborhood, right like here, which means these are, again, yeah, I can clip them just a little bit shorter. So let's go ahead and trim this one down so it gets about to, about halfway along the belly pan on that side. Right, and of course yours, if they're brand new, you're going to have to cut way more off of your wires than I did. And let's get a connector on here. Always tug on it. Okay, and I decided I kind of want this connector to be next to that anchor that I've already got. So these wires are already the right length for me. I can't make them any shorter, so I'll go ahead and strip them now. And another connector. Oh, wait, no. I just need the other end of the connector I already started. All right. And that one's going to live somewhere like there. And then this one is going to live, I guess we might as well go to this connector that's over here. That is already over here. So I'll cut this one down a little bit as well. Something like that. And like that. I guess let's strip the other can coder wires too. And then we'll get them all into a connector housing. Again, be careful. Don't just jam it in there and be like, okay, the wires mostly made it in. Make sure you get all the wires into the connector. That's going to be important. All right, give it a tug test. Cool. So we talked about like how, as I'm going to go ahead and zip tie these connectors down, we talked about how like your main power is super important because if your connections are loose, it's basically going to rob power from your motors and stuff like that. In this case, a bad connection means that the signal might not be great. And if the signal isn't great, your motors aren't getting their commands, their orders, the way that they need to. And then that can also lead to the robot being a little erratic. So it's important basically that all of our electrical connections are as nice as we can make them. And I just attached that to the power wires that are there. You could probably have put another anchor down and connected to that instead. But this seems fine to me. Just don't want, especially the connectors, right? The connectors have some more mass than just the wires too. Which means if you leave the connectors just loose like this, and your robot drives and hits something and this is shaking around, well, moving wires is a way for stuff to work itself loose as well. So that's another way in which you could run into a problem. So I'm just going to piggyback right on top of the wires that are here. All right, so these connectors now, right, they maybe can wiggle a little bit. For the most part, they're not moving. Okay. And then we've got our motor, second ends of the motors going out. Yours shouldn't be cut yet. We'll figure out how long they need to be once we get the last module done. And then we got the CAN coder power coming out that we're going to have to figure out. And that CAN coder power, I don't know which direction we're going to go. I might go to the left to join up with the other CAN coder power first. We'll see. We'll just see how it goes. All right, let's clip these ends. All right, and if you haven't already done it, do the same thing to this one, right? So you'll have the CAN coder power and one long, at this point, uncut, unless you already have it cut, in which case your longest end should be leaving the module. So one from each motor, and then the other ones, again, we're going to do the same thing. Motor to CAN coder to other motor, get those in a connector, get those bundled up. Okay, we've done this corner as well. I just followed the exact same pattern. Zip tie here to hold it, zip tie here to hold it. Got the connectors on each side. And again, that's the CAN coder to motor, CAN coder to other motor. And then we've got our CAN coder power coming out and one CAN wire, yellow and green CAN set of wires from each motor on their way out. Okay, I think let's start now and we'll do the chain in order. We kind of did a shortcut at each module, but now let's go ahead and do starting at our canivore. So we have the canivore here. I think probably, well, it doesn't matter. We're going to take the one wire that's coming out from the closest motor to where that is, and that wire is going to run. We can route it however we want, but that is going to come over and plug into our canivore. And remember, we want a little bit of a loop there. So I'm only going to trim mine a little bit. I'm going to cut about to here. Right, because I'm going to go along these wires, down into here, big loop, and plug in. Yeah, that looks good. All right, so we can strip these wires. Okay, and then I'm going to just undo the canivore here, or unvelcro it, which we already did once, so no big deal. All right, it is labeled on it. So we have CAN low, G, green, CAN high, yellow, and then voltage plus and voltage minus. We'll come back and do the voltage in a second. We're just focusing on our CAN wires. So if we find the port that is green, we're going to take the green wire. The green port is the top one. And there are these little beige push buttons. If you want to take the wires out, what you end up doing is you push down on that button, and that will release the spring that's holding it together. But to put the wires in, usually, not always, but usually, you can just take the wire, and there's a hole underneath the beige. If you just put the wire in the hole, and you can keep the strands kind of nice, and push straight in on the wire, it usually will slip in for you without doing anything. So I just pushed in, now I'm pulling on it, and it's not going anywhere. Now, if you're pushing in and the wires just keep bending and it's not happening, then you will have to push down on the button at the same time as feeding the wire in and letting go. Okay. Let me make sure my green one, actually I'm going to push on the green one and make sure that's in all the way. I think it wasn't quite in all the way too, so that, you'll have to check it. Sometimes with these tiny wires, it just depends on, how straight the ends are and how nicely they go in. But with this, just like with every connection, pull on it, it should be really snug. You should be able to give it, I don't know, like a real little tug there. And it should stay in place. Okay. The other thing with these small connectors is I'm going to look here and make sure there's no wire strands sticking out. That can happen a lot. And if you get a wire strand from each wire sticking out and they touch each other, that will basically short everything out. That's going to ruin your ability to control your robot. All right. So now we can go ahead and I'm going to just stick that back down for now. you know, you can zip tie now as we go. I'm going to kind of zip tie as we go, but you can also wait and just do all your zip ties at the very end to clean stuff up. But I'm going to get one, and I'm just going to use you can do more anchors, but I'm just going to use the power wires because the power wires are pretty sturdy, especially now that they are also, you know, anchored down to the board in a variety of places. So I'll get kind of one on this side just to hold that whole bundle that's leaving the motor together, and then one over here just on the way into the canivore. And if you're worried about this part, if this part is moving on you, you could add one more kind of in the corner to go around. I'm going to see if that just stays in place for me. All right, so our signal starts, well, hold on. Let's get our USB cable that came with the canivore. And we'll go ahead and plug that in. I'm going to undo the Velcro for a second here. Okay, and the other end plugs into either port, USB port on the, got to plug it in the right way, on the RoboRio. Okay, and then we've got all of this extra wire that we want to do something with. And I think it's basically like in a bundle down here like that. Seems perfect. So now I'll go ahead and use that Velcro to hold it in this shape because that feels like a good shape for me. And that seems like, again, make sure it's not really torquing these connectors left or right. You've got a bit of a loop on both sides going into where it plugs in. We never want to have any connector, right? Like this was a little bent too much for me, so I'm kind of pulling some of the wire out of the bundle just so I get a bigger, more comfortable radius there. That looks good. So right under kind of the middle where the Velcro is, seems like the right spot for it. I'm going to drop a little anchor. And let's zip tie this down so it doesn't move on us. Bundle goes in. Okay, and last check. Good on all my radiuses. Yep. So I'll snug that up. All right. So now the signal starts at the RoboRio, or the RoboRio is going to do the communicating, goes to the canivore, which is going to basically communicates in a different way with the RoboRio, but then now everything coming out of this will be that CAN FD. Then that is going to go into our first motor right here. That motor is going to go through our connector into the canivore, or sorry, the CAN coder. The CAN coder goes out through our connector to the second motor. That second motor now is this one going out, and we got to get this one to our next module. So now we're going to head towards, actually, that stupid C channel is going to be in the way. All right. Now we got to head towards our second module here on the front. So this is the wire coming out of the first module. We have two wires coming out of the second module. Now here's the problem. I want to save this one because I want to show you how to use that connector, or we're going to use that connector in one place. So I'm not going to use my one good one. I got this super, super short wire here. They will reach, so that's what I'm going to do. But for you, you should route this wire down along here, and this wire you should cut so that it ends up, you know, in this area here, so that you can connect those together and then zip tie that down to the board in that space we have. Unfortunately, because my wires have already been used and they're a little short, I'm just going to use the full length that I have and connect them together. So I have more of these connectors. Again, just keep using whatever connector you've got. If you run out of one kind, it's OK to mix and match. And I'll go all the way up to here. And connect that one in. Okay, and then we are going to pull on every single wire there, and that's good. And so it looks like for me, unfortunately, right, my connector is going to be in a really, really bad spot. Like, because I'm not competing, it's fine. But you are competing. So again, I would take this wire that's coming out of these motors and trace it down, and I would want this connector to be in this area next to the RoboRio. All right, but I'll do my best, I guess, to kind of anchor that wire up out of the way. Let's see what we can get. Let's see what we can get it to up here. That's crazy. That's maybe the best I can do. So I'm going to go, so basically about here. I guess I'm going to grab, yeah, that's really it. Man, I wish that was a few inches longer. All right, that's fine. I'm going to just throw an anchor down. And mine is going to be up here on the side of the robot, where I do not recommend you put an anchor. That's already used zip tie. That's not going to help me. So again, this is not, do not do this. Do not put this here. This is not a good place to put this. Don't do this. Don't do this. But my wire was too short, and I don't have a choice. I guess if your wire is also too short and you don't have time to get a longer wire, you know, this one is questionable whether this is better or whether adding another connector in the way is better. But again, if you have the brand new wire, route it down around, get your connector down here where it's going to be nice and protected. I'm going to do one more zip tie anchor on the inside of this wall. And we can start rotating to the next position anyway. So we'll get the inside of this wall, and I'll do a zip tie to do my best to hold that somewhere. But like I said, this anchor position is probably a great zip tie anchor position, but your connector should be here. That's where I want you to try to get your connector if your wires are long enough. You know, here or a little bit farther along if necessary. Probably a little farther along is where the other wire will reach. All right. So we can continue now. Okay, so canivore into one motor, through the can coder to the other motor, out from the other motor where we just connected. That now connects into one of the motors on the front module, to the can coder on the front module, to the other motor on the front module, and now this is that wire coming out of that other motor on the front module. And we said on this side, we have our pigeon, our IMU here, and that pigeon also needs to get connected to the can chain. And just because, you know, I like keeping it factory fresh, the pigeon does not have, right, like the wires are not wires that we screwed in. They're not ring terminals. We didn't attach them. They're sort of like factory connected inside the frame here. So that's why sometimes I like to just keep these ends on. I probably, if it were a competition robot, I might cut the wires down just to be able to use the lever nut connector, which is a little bit more reliable connector. But I would probably, on this one, cut it and leave the wires really long. So, you know, whatever. Like if I'm routing this over and I know I'm going to plug them in like in a spot like this, right? Like I could cut it there. But because this is not reusable, what if next year I reuse the same pigeon and I need the wires to be a little bit longer? So if you are going to cut this one, I might deal with the extra wire and cut it out close to the connector so you have the maximum length to keep using. But for me, I'm going to take the wire that's coming out of that module, the motor module on the front, left, and one of the wires coming out of the pigeon. And of course, it doesn't matter at this point. They will line up because one is the female side and one is the male side. So I'm going to have at least one of them that is correct. And we'll plug that in. And then this, right, can separate on us. So in order to stop that from happening, if you are going to do this, you need to add some tape to hold these together. Okay, so just make sure first make sure it's yellow to yellow, green to green, and then basically what I do is I just get the tape right across the seam, and I make sure they stay plugged in nice and tight as you're doing this. And then I'll wrap it around a couple times. And then because sometimes you might need to get these apart to work on stuff, I will fold the end over to make a little tag to be able to peel it back. And you can see that's pretty good, but they can move a little bit inside of there. So this isn't the best connection. So the other side of our pigeon we will do in another way. But let's go ahead and route this wire first. So this one is sort of like how we were talking about on the front here. If I follow the power wires that are going around through here, I can tag on to them. Well, I guess I just wanted to flip the robot around. Kind of started turning it a little bit, and then I was like, all right, so we're going to come down along this whole bank of wires here. So I can throw a little zip tie on there. I'm going to keep all this stuff sort of inboard of the outside of the robot, so it's not going to be the first thing that gets caught. And then sort of come around this corner here with them. And then we can kind of ride along the main power wires that we have going through there. So you might be able to sneak one on the inside. I think we do want a zip tie here right away, just to make sure we can force it away from, again, the corner of this channel. Mine is cut. If yours is cut, it's going to be a little sharp. Okay, and then basically we can take the rest of this and just run it over to a place where we can bundle it up. There it is, and do one more. Oh no, I lost it again. And do one more zip tie here. All right, so just an example. That's also how you would do the modules if you're doing the modules without cutting anything. But I do think getting the real connector is better. So what I'm going to do on this side, right, now we're into the pigeon, out from the pigeon. We have the other set of pigeon wires. And I've got a couple long wires coming out of my other module up here. And, well, I guess we have both ends coming out, right, because we have each wire. Well, I guess you might not have both ends coming out. If you didn't bring out the right end to match to this, I should have probably mentioned that earlier for you to be able to plug that in. But I like the idea of, anyway, going to a better connector here. So like I said, what I want to do on the pigeon wire is I want to cut as little as possible off of my pigeon wire, because that one is the harder one to replace. So I'm going to go basically to the end of the connector. Sometimes I like to leave just a little bit, because then I could actually strip this and use that connector to reattach a connector to places. So I'm not going to cut it like right off at the connector, although you could. I'll go a little bit lower, maybe say an inch down. Snip that there. Okay, and then we'll strip these. And I think this is a better connection, right, than relying on just those connectors being pressed together. So if it were me and this were my robot for competition, I would probably not do any of the taped connectors together. I would only do kind of these lever nuts or some sort of more permanent connection. All right, we are going to run out of these connectors soon. I want to save, if you're running out of these connectors, save one. We need one of these double connectors for the very end. Okay, and so this, we can probably go under the power wires to keep it smooth, and that'll give us like a good connection point right around here. So if I take this one, and I want to route that also, making sure it stays away from that sharp edge. So I'm going to cut that one also basically right at the end is where I ended up measuring it. So I'll snip it towards the end here. Strip those wires. And then we'll plug them in. Pull on them. Feels good. Let's go ahead and start doing some wire routing here on this one. I think I'm going to undo the ones we just put in. I think I'm going to go under these power wires that are hanging out here. And then plug it back in. That seems good. All right. And then I'm going to get one for sure zip tie out here. Just keep it away from the cut edge there. Okay, and then for this one, we'll do a bigger zip tie, and I'll get it attached to the frame rail here. For the connector, again, I don't like connectors bouncing around, so all of my connectors are going to get anchored in. Okay, we'll try that again. All right, that connector is not going anywhere. This wire is now really nicely protected. It's got a little bit of a lot of travel on the other side. So I might do one more little strain relief to our power wires right here. Okay, leave a little bit of a loop, tighten that in. Okay, now that wire can't get us into too much trouble. Okay, next. Let's move this over just a little bit. All right, and we have this. I wish I never attached the battery cable yet. All right, but we did, so too bad. All right, we got our power wires here for the CAN coder that we're going to have to deal with later. And then we've got our last set of motor CAN wires coming out. And this, right, has to connect to the back Swerve modules. So I'm going to take one of the, actually, and we want this specific one, right? So find, on your back modules, find the motor that's closer to where we're working. Okay. And just because like it doesn't make sense to crisscross the wires, right? So we're going to go from this motor right here to the extra set of CAN wires we have coming out. We can choose where we want this to go. I'm guessing it feels like it's going to be under the power wires is the way to do it. And maybe we can route this one like here down under the power wires, and this one out a little bit and over, and that'll give us a connector spot, you know, somewhere, yeah, somewhere right around there. Okay, so this one I want to be as long as possible, more or less. So I'm going to follow the same rules that we did with the pigeon, which is leave a little bit. Just, you know, there is a chance this might be useful for us in the future. Snip that. All right, and I am now out of the fancy yellow and green double connector one, so I'm going to do a bunch now with these included in the kit connectors. So we'll go green and one for yellow. That gets all the way in there. All right, and tug, looks good. Okay, and then we say these are going to end up like here-ish. So I want a little bit of a loop on that to go out and back. So I'm looking at cutting about here. This one's going to get real short. If you want to leave yourself, again, you can always leave the wires long, bundle them up, and leave yourself some extra room for a future arrangement or change. But we can unscrew these and put new ring terminals on. So you can always make brand new wires for the motor side. It was a little, maybe not. It felt a little short, but okay. Make sure it's yellow to yellow and green to green. Tug, it's good. Tug, it's good. All right, so these we're going to have sitting down somewhere around there. That feels like a job for another zip tie anchor. So right about there. Both of those locked in, perfect. And then, let me see, I'll use a little zip tie just on this side to hold this to the motor wire. So we got a little bit of support there. Good. And then this is kind of a long stretch of unsupported wire, so I'm going to throw one more anchor around, let's say this area here. Kind of hard to reach down in there, but yeah, man, these power wires. All right, we'll go ahead and pull that zip tie on. Anywhere down there with an anchor is going to be fine. Doesn't matter if it's in this exact spot, for sure. And even if it's not super tight, it's going to probably be okay because it's really just a matter of us trying to keep that wire from being able to wiggle around too much. Can I even reach down there with the... Yes, just barely. All right. Now, on our last module, so I mean, like, let's look at the big picture again, run through everything. So we start at the canivore, right? That wire goes into our first module, which we know goes motor, can coder, motor, out to the second module, motor, can coder, motor, into the pigeon, out of the pigeon, into our third module, can coder, motor, out to our last module, motor, can coder, motor, and now we have one wire coming out of the very end. And this wire is the end of our CAN bus. This is the end of the whole wiring section. But we need some way to tell the robot, or to tell, basically, really we're telling the canivore, like, that's it. This is the end. The signal goes no farther. We need to deaden the signal and stop it from coming back. And the way to do that is to use a resistor. So there is a built-in resistor on this side in the canivore that's going to take care of that side of our CAN bus. The other side then will need another resistor. So that's what I have here. You need a 120 ohm resistor, and you can basically get any type. As long as it's 120 ohms, you're probably going to be fine. This one, I don't know what this one was. Quarter watt, half watt. They just get bigger, but they're all going to work, and the actual power requirement is not massive. And this is why I said, hey, let's save one of these connectors for this. So if I open this connector up, what I can do is take my resistor here and kind of bend those leads in so they're going towards the connector here. Now your leads are probably going to be longer on your resistor. So what you can kind of do is see about how far it goes in and try to leave about that much wire left. And you can just snip those with a cutter. And it doesn't matter. Resistors work the same forward and backwards, so it doesn't matter which way you put it in. There's no polarity to this. But basically, I'm going to just shove that in there as far as I can. And if this is sticking out a little bit, like if you have some extra wire there, that's not a big deal. It's actually most important thing is to make sure that the wires make it in to the connector so it can close down on it and have a good connection. All right, and so when that's in, you should give it a little bit of a pull. Not like a massive pull, because it's just the legs of our resistor. But I've found that on this one, right, this one goes down to a small enough gauge wire that it's going to work. Now, if you don't have any of these, I would not probably use these ones that came in the kit of parts, because again, these are only supposed to go down to 18 gauge wire, and I can guarantee that what's coming out of the resistor is probably closer to 24 gauge wire, and you do want a good signal here. So this has worked well for me in the past with this style of lever nut. If you only have this kind, I probably wouldn't do that. I might go get some of these smaller ones that work with 24 gauge. And I've used these with resistors all the time in a bunch of like random projects where I'm just kind of hacking stuff together. All right, so we can open the other ends, and those ends are going to go on the wires that we had for our other motor. So we got to figure out where we want this connector to live. Do we want it to live on top of the other connector that's here, or do we want it to live, you know, just on its own in the corner over here? And I think these wires, right, we know these wires are going to double around, and they're going to be going out and up this way. So I kind of like the idea of putting it, you know, in the front up here. But because we might want to attach other stuff there, this time more than other times, because I'm going to kind of attach this in a random place in the back here, I'm going to leave myself room to change my mind to go over here. So I'm going to measure out, like if I wanted to go to this connector over here, you know what, I've changed my mind. I already like this position better. So that's what I'm going to do. It looks clean. This first connector for me, like there's not a lot of room next to it, but the second connector, I've got a great spot right next to it for stuff to go. So that's what I'm going to do. So I'm going to route this wire to like that position, and that's where I'm going to cut it and strip the wires. Okay, and then after this, before I connect it, I'm going to do one more thing to my lever nut connector with the resistor. I'm going to do one more thing to that resistor. All right, so those are stripped. I'm going to grab some electrical tape. And the one thing with this resistor is it can't really short out because it's not strands of wire that can move. But no matter how you do it, there's going to be some exposed wire on the sides of the resistor here. And it is possible, depending on how they're sitting, right? Like if those wires both, for example, touched the frame of the robot, that would short out the resistor in the sense that there would be no resistor there. And that would cause you some communication issues. So instead of letting that happen, just going to get a little bit of electrical tape here. And I'm just going to kind of go over the resistor. And then probably not necessary. That's probably enough, what I've done there. But I'll also go around this way, because we don't really need to access those levers to open it up or anything like that. So we'll go around this way. Just know that now we can't see the resistor that's in there. So you will have to basically take the tape off. If you're having communication problems, you might need to take the tape off and make sure the resistor is still there and still connected well. All right, so now we can take this back over to where we had those extra wires. And we're going to go... Actually, this one, it doesn't matter. I'm putting the yellow one on the side with the yellow lever, but it doesn't matter because we're just going through a resistor, which is bidirectional, works both ways the same, and then out. So, you know, if you plug them in backwards, that's your one chance to plug them in backwards. Don't do it, though. It's just confusing. There's no reason to do it. I'm going to give this one its own zip tie anchor over here. Stick it down next to the connector that's already there. I should have put this slightly farther out so that the zip tie would be easier to fish through, but that wasn't bad, actually. Never mind, I changed my mind. Huh, this is another one that isn't clicking. Did it get tight? Did it stay tight? Okay, all right. I don't know, it seemed like it worked. So we'll do that. And then one more small zip tie somewhere just to keep the wire lead that's coming out here from moving around too much. I'll just go to the other little CAN wire that's there. They can use the buddy system. All right. Okay, that is a complete wiring of our CAN bus. Well, our CAN FD bus. We're going to have to do a second CAN bus to control our other devices, and those are going to plug directly into the RoboRio when we get to that point. Okay, so we can either do that CAN bus now, or I can trim these zip ties that I forgot about, or we can do the power wires for our Carnivore, Pigeon, and our 4 CAN coders. I think let's try to start figuring out the power wires. But once again, I have a ton of cut zip tie ends and stuff that are littering my table. So let me get rid of some of my garbage again, pack some of these cut wire ends away. I'll save them for a rainy day. I'll probably never use them, but you never know. And then we'll come back and we'll get the power lines tackled. All right, so up next for this, we're going to need 18 gauge wire. I think there's a spool that came in the kit of parts. But if not, any 18 gauge wire is going to work. Red and black is good. We want to keep the polarity matching. So red, I think on the supply side of things, red always needs to be the positive voltage and black always the negative. Now we have all of these connectors. We have 1, 2, 3, 4, 5 of them. And the Carnivore is going to need some wires coming out of it. So we actually have 6 sets of power that we're going to need to supply. We could run each one to a different spot on our distribution panel or hub, whatever you have, and each one could get a different circuit breaker. Now, that's a little bit wasteful. That might be the way you want to go, and that's fine to do it that way. We obviously have the extra ports, no big deal. It's going to take a bunch of extra fuses. I think the pack of fuses that we got in the kit of parts is already going to be, breakers, is already going to be a little short. We have 6 40 amp breakers, which isn't great because we actually need 1, 2, 3, 4, 5, 6, 7, 8, plus 2 more for the fuel mechanism. So we actually need 10 40 amp breakers. So you'll have to buy more of those. We'll talk more about that when we get to it. But it also only comes with 2 20 amp breakers. So if we were going to power this stuff from one of these ports, we would want a 20 amp breaker for that. And so you'd have to buy a bunch more 20 amp breakers as well. So it's kind of your choice if you want to do that. That is one way to do it. Now, some of these wires will reach, which is nice. Some won't, so you'd have to extend those out. What I'm going to do here, and let me bring up, I think this is a bigger spool of 18 gauge. We're going to use all of it. What I'm going to do is they make lever nuts that have more than 2 wires being connected together. So this one, for example, has 3 spots to connect wires together. And I also have one, and I don't know if this is going to be helpful for us today, but this one connects 5 wires together. So in theory, right, I have 1 wire leaving this to plug into our power distribution panel. If I plugged in 4 more wires, all 4 of our CAN coders, then that would take 1 port on here in order to power it. So this is nice. One of the rules, I believe, is still a rule. Of course, for every time I say, hey, there's a rule, you should always check the rules yourself, because I'm not the rules expert. You should be. But I believe there's a rule that says you can only have 1 wire going into a port on the power distribution hub or the power distribution panel, which means I can't just take, this wire and the wire from another one and stick 2 wires into there in order to avoid having to use multiple ports. But if I use something like this and connect 5 wires together, 4 wires together, and have a single wire coming out and plugged in, then that would be legal. And that's going to work just fine. So I think what I'm going to try to do is connect our stuff together and see how that goes. We can do this in a couple different ways. It looks like, again, we have 2 20-amp breakers. It looks like if I take the 2 power lines on this side of the robot for these 2 CAN coders, if I connect those 2 together and feed them in, that's one side done and 1 20-amp breaker done. And then on this side of the robot, so we don't have to cross over the robot, I can do 4, 1, 2, 3, and then the canivore would be 4. If I connect all of those together, I can take 1 wire and pass it in. But we have some options, and I'm not sure. I'm still undecided as I speak to you about this, which way is better to go. I could take, like, for example, these 2, connect them together, right, with one of the 3-wire ones, have 1 wire coming out, connect these 2 together with one of the 3-wire ones, and then have 1 wire coming out, then connect those 2 wires into a second 3-wire one and pass it in. Or I could connect, I think these 2 would be close enough to directly go into my 5-wire one. And then I could just use regular extension wires for these 2 over to my 5-wire one and then pass the last wire in. I think I'm going to go with the second way. And the reason why is not because I think it's better. I actually kind of like using a bunch of the 3 ones and pyramiding my way up. I think that sounds fun. But you have a bunch of these Wago lever nuts that came in the kit of parts that are single extenders. And so I'm going to use the way that uses these and forces you to just buy 1 of these 5-bay ones. And then on the other side, we'll need 1 3-bay one in order to connect everything together. So let's start on the easier side. Let's start on the smaller side where we only have 2 sets of wires to deal with. So first thing is if I get one of my, well, okay, when I said 1 5 and 1 3, I meant for red wires. And then you need a 5 and a 3 for black wires. So you'll need double of what I said. All right, so let's get one of those 3-wire connectors. I'm going to lift the lever. And this one is, it doesn't really matter where we go, except that one of these guys is going to have to get extended. And I have space over here, kind of where we brought our other connector in. So I'm going to attach the 3-wire one here. I'm going to throw 1 red wire in 1 port there. And then I'm going to get another one, open that up, and I'm going to throw the black wire in another port. All right, and these, I don't know, we'll probably zip tie it to the connectors that are already there. Guess we could zip tie it to the motor. I don't really want to go that far. I like the idea of these kind of being, something like this. We could do another zip tie anchor in this area. Okay, that's fine. Let's say it's going to go somewhere around there. Now, the wires coming from my front right module here, they are not going to reach. In fact, even if I just try to stretch them together, they're not going to reach. Maybe if we went directly straight through in the air, but that's a bad idea. So we need to extend these wires out. So let's get 2 of those regular Wago lever nuts and drop 1 on each side. Cool. And then for the other side, we're going to need some of that 18-gauge wire. So let's untwist some of this. All right, and we can just sort of, it's really, this is kind of sad wire because of how stiff it is. You can see how much it's holding that twist that it had compared to the wire that we were using, which was a very flexible, high-stranded wire. All right, so this wire is going to go, and one of these is already, let me get clean ends here. One of these is already stripped, and I think that's not, I guess that is what we want eventually, but all right. So we're going to go in here and in here. We're going to go down to the bottom like that. These are going to sit underneath those power wires again. So we need a section of wire that's about that long to reach those 2 places. Again, you could leave a little bit extra just in case. But this is such a small section, if you cut it and it ends up being too short, that's not a lot of wire wasted. So we'll snip that. Got 1 red and 1 black. If you really wanted to, you can, you could twist these together like our other wires are twisted together. In fact, if you take a long section of this wire and you chuck the wires into the drill, you can turn the drill on. If you have the other end clamped to something or in a vise, can turn the drill on and that'll spin them. But for the most part, I'm not going to bother doing that, especially with these really small sections. Okay, let's just strip all 4 ends of these 2 wires, so both ends of each wire. Other side. All right, and where are those connectors? I tucked them under. Okay, make sure the black wire goes with the black wire. Tug on it. Red wire goes with the red wire. Also tug on it. All right, and now let's go ahead and route these under the power wires like I was suggesting. Okay, and then we've got our little pack of wires here. I'm going to open up the red one for the red wire. And these don't matter, like these are completely connected together, so you can, whatever order, whichever spot you want to put it in, all the same. Black wire goes in, all right, cool. And then we'll, find some way to zip tie this down. We can zip tie that one down on the other anchor that's already there. So I don't know, we might piggyback on this one. We might do our own one here. Either way, our next step then is going to be we need to route wires from roughly this location to, good thing we left that first spot open, right? Like, I mean, I guess we would have been going here otherwise, which is not that big of a difference. So, all right, so something like that feels pretty good for a length. So snip them. All right, and once again, strip all 4 wire ends. Alrighty, black wire into the black bundle. Red wire into the red set. There are some other options for this. I think these connectors are the simplest if you can find them. I know they sell them like on the big online places. So you should be able to find them. You can solder these wires together instead. There might be some other connectors that work. There are sometimes other mini terminal blocks that you could use. But just getting a couple of those connectors is pretty cheap. All right, that's in. Pull on it. Not going anywhere. Let's get the other one here. And that's not going anywhere. All right, let's get a couple of our zip ties in. I'm almost out of the zip ties I was using, so I'm going to have to switch zip ties, which will also switch zip tie color. So hopefully that doesn't throw you off too much. OK, that anchor is not really going to give me room for another one. So I'm going to just sneak one more anchor down into this area if I can. Actually, wait, before I put the anchor in, I'm going to put the zip tie through it. Now I don't have to worry about fishing that zip tie in. And actually, I can use the zip tie to help me get that down into a spot where it can be. All right. Now we can kind of set those on it and zip tie it in. Cool, that end looks good. I want to get this, our other connector set here, connected to this zip tie anchor that's already here if possible. You know what, I'm gonna, this one, because it's simple, I'm gonna snip the zip tie that's there. And then run a bigger zip tie to grab everything all at once. If I can. All right. These power wires. All right, that's bundled up. It's not going to shake around too much. Okay, and then this one, you know, I think I'm okay with this one. But there is a world where you could have left it longer and gone to the other bigger wires, but that feels pretty decent to me. Okay, we can even, maybe I'll even tuck it down here so it runs a little bit lower. So we have room. We're going to plug stuff in here later. Cool. Now on the other side, I'm going to get 2 of those 5 bankers. And, well, this seems like a lovely place for them to end up. We got a little bit of space here, and so that's pretty nice. I'm going to start out by opening up. I don't know, do we just open all of them now? Maybe we'll open all of them now. All right, and I'll start with the pigeon, because it's got the wires kind of right next to where we're going. Now, these wires are going to be too long, but again, I already talked about how I kind of like leaving the pigeon wires long, just for future use. So I know we'll have to do something with those eventually to get them out of the way. All right, and now we've got our, I guess, our front left module here. We can get these wires that are coming out from the front left module and get our regular connectors from the kit going on there. And I think we will take a pause and add a couple of zip ties for these. All right, so I need one kind of down here to hold it. And then now we get to choose where, oh wow, that zip tie is, I don't know if that's a better zip tie, but it definitely takes more to get that to go. So I think like if our connectors are here, that's not a bad thing, because the connectors certainly are durable. So I think connectors there is great. Let's get some more wire. So this wire is going to have to route from here down to somewhere around there. I'm going to cut this one a little bit long, and once we have it sort of zip tied in, we can trim it to final length if necessary. This time I'm going to just strip 2 of the ends, so one on red, one on black, because again, I just said we might trim it down to length later. All right, so make sure red matches with the red wire, tug on both ends. Black matches with the black wire, also tug on both ends. All right, and then let's get a zip tie for this. Keep those connectors from bouncing around. That feels good. Right, and then these 2 wires are going to just sort of jump down here. And we are going to plug into these, which again, we know we're going to try to zip tie anchor like in this neighborhood. So, all right, let's see. How much do we want to leave slack-wise? I'm going to take just a tiny bit off, I think. I'm kind of leaving myself enough room to put the wires in this direction or put the wires in this direction. So I've got a little bit of an extra loop there. Still wish this wire wasn't quite so stiff, but it's all right. Okay, red. Get our bank of red ones here, which consists of 1 red wire so far. And then black. 2 down. All right, 3 more to go. Next up is our back left module. So we got the wires just barely hanging out here. We got to do the same thing. We got to extend them. They're a little bit too short. So we'll throw a connector on that end. Connector on that one. And that seems fine. We'll go to here. So we need wires to go kind of from here, around over this way to there. So something like that seems pretty good. I'll just strip one end of each wire this time in case we want to trim it more. All right, and the black wire gets the black wire. The red wire gets the red wire. Let's go ahead and put a zip tie. Guess I'll just go around these wires that are already here for our connector. That seems reasonable. I can't get it to, there we go. Pick up off of the belly pan. All right. Kind of something like that. It's pretty good. Because I think this one is going to be a little bit in the way. Well, and now, why not? All right. And then, right, like we're going to route around, get to this. I feel like that is a pretty good length. So I'm just going to, yeah, that feels good. Let's go ahead and strip these and add them to our little blocks. Black wire joins the others. Red wire here joining the other red wires. All right. Next is our carnivore, needs power. And so that is going to go right next to where we plugged in our CAN wires for it. So we're going to have two wires coming out of there, and then giving them enough room to loop around to get to the things here. So something like that. I'm fairly confident this is the right size, but I'll still just strip one end to start with. All right. And then, once again, for the carnivore, I'm going to pop this off its mount here and tip it up a little bit. So we have V plus, and I think it says R, and V minus, and it says B. So that's the other two ports here. So on the outside edge is going to be the black wire. And this wire is very stiff, so I think we actually have a decent chance of just pushing this wire in and not having to deal with the button at all. Oh, yeah. That went right in. Tug on it. It's good. And then the red wire goes next to it. Okay, and then again, yep, that label, red and black, perfect. Okay, then I can just go ahead and, well, I'll get rid of that wire strip end there. We can route these now around. And yeah, that seems reasonable. Let's go ahead and, wait, why are these? Oh, they're a little bit different lengths. I guess the red wire has to go a little bit farther anyway, but. All right, let's strip these wires. We're going to pass them under and join them to their blocks. Let me see, I'll go that way into there. And then this one. There was one wire acting up. Cool. And then the last thing we got to do is get this wire to one of our ports here on our power distribution. And it really doesn't matter where you want to go. It seems like maybe cleaner to go to this backside, but more accessible to go to the front. So these guys are going to be in. It looks like they're going to end up sitting in there like that. All right, so we're going to come from, looks like then I have it backwards, but that's fine. So we'll be from like here to like, I don't know. I'm going to cut this one extra long, and then we can figure out how it feels when we go to route the wires. I think this is also long enough that if I chose to go this way, I'm going to have plenty wherever I want to go to plug it in. Okay. Wire strippers. This one for sure is too long, so I'm only going to do one side. And we'll go into one of our things and into our other Wago 5 port. Cool. Okay, now those two wires, I guess now we anchor this down. That's the next step, is we anchor this down and then we figure out where we're going. So, okay, that seems like a great spot. Let's get an anchor, zip tie anchor, and a zip tie. I'm going to use that new trick. Can't believe we were almost done wiring the whole robot when I realized we could do this. Wait a minute. This zip tie does not fit. Let me go back to my zip tie drawer. I think these fit. They're just like way longer than is necessary. So, all right. I'm going to pass the zip tie through to start with. And then we can go down and stick it in a spot. That seems good. Okay, and then I can put these down. On it. We'll see if we can get on the connector. If you can't get on the connector, but you gotta get all the wires near the connector, that also is good. Again, we just don't want this to flop around too much. It's gonna wiggle a little bit, but that seems pretty good. All right, so that wire we'll do something with. These wires maybe we'll do something with. And then these are the wires that are leaving for us to figure out where we want to route them. I'm gonna go this way. I'm gonna kind of tuck down underneath these other wires here. And I'll go underneath again. Sure. Seems pretty good. I do want to add a couple of zip ties here as we go through. I don't know. Maybe we should have gone the other way. All right, I'm going to do this direction still, but I'm going to go up here on top where I can kind of see what's going on still. So that means, okay, that means we're going to jump up here to the top where other stuff is running along. And I can kind of just probably zip tie to the zip tie that's there. All right. And then zip tie to the next zip tie that's there, and then we're ready to go. Yeah, that seems way easier to do than whatever I was trying the first time. All right, and then these are going to go into it's kind of our choice, but I guess it's going to be the next port that's here. So that seems like about the right amount of wire for it. So I'll cut it about there. And let's strip these 2 wires. Lift up the levers. All right, and this will be blind to you, but you've seen it done 100 times, so get it in the port, drop the thing, and pull on it. It's good. They went in for me, but don't forget, if you have to, you could pop this up off of its Velcro to take care of that. All right, this is good. That's good. This is good. The last thing is just all of this and the little bit of extra wire bundle from the Pigeon. I feel like if I just bundle that together, that's going to be good enough for me. You could try to get a zip tie anchor in there if it felt like it was going to give you some issues. I'm just going to get all of those wires coming into my bundle and just let them hang out together. All right, you can kind of even tuck them a little bit underneath the RoboRio since it's up on the high, thicker Velcro. All right, that is power for all of our CTRE devices. Next up, let's get power to our RoboRio. So for that, you're going to need a flathead screwdriver. And right here, I'm going to unplug my USB just so it's not in the way of you seeing what I'm doing for a minute. Remind me to plug that back in. If I don't plug that back in, I'm holding you responsible. All right, so there is this connector right here. I meant you, the person watching the video, not anybody else in this room, of course. On the side, so there's V and C. So one is for kind of our voltage in, and the other is common or ground. On the sides of that, there are little spots for the screwdriver to go in. So go ahead and unscrew the screws that are on the sides there. Okay, and you'll know it's unscrewed when, if you grab this black connector and lift, it comes out. If it doesn't come out, keep unscrewing. Okay, now on this connector, if I tip it forward, on the top is another set of screws. So these screws here on top are another flathead screwdriver screw. And those screws, when I tighten that, you'll be able to see, on the one you have at least, it will close down this port, these 2 ports here. So that's where the wires go in, and then we screw down the screw until it gets tight. So make sure your screws are open a little bit. And you can look in there and you'll see like there's a little metal jaw that like moves. Like as I screw it in, you can see that kind of moving up and down. So just make sure that's open for a second. All right, and then I'm going to set this gently down on top of the RoboRio and try not to lose it. I'm going to get some wire. This again is going to be 18 gauge wire, that same spool that we've been rocking with. And this wire needs to go all the way from this port on the RoboRio. It's got to get all the way to those mini ports on the power distribution hub that I was talking about. So we have these, instead of the big levers, we've got these little levers here. And so these little levers is where we have to get to. And we can use either 20, 21, or 22. You cannot use 23, not the orange one that says switchable. So we can go into any of those. I guess 20 is probably the closest. So let's see. If I try to route my wire from there, how much wire do we need, right? So from here, we can go above or below. It's going to be roughly the same amount of wire. Maybe we sneak inbound here, come around this way, join the whole party, leave ourselves a nice loop, and then leave some extra because, you know, we don't know where it's going to end up. All right, so I'll cut it somewhere around here. Again, leave plenty extra. Actually, if you're down to like this much wire, we could wire the one side and just route all of this through, and then, you know, you would know exactly how much you need. But I do find it's like nice to get a little bit smaller pieces to deal with. Okay, and then let's strip one end of these. Okay, and now in that connector, but actually, where did I put my screwdriver though? There's nowhere for it to go. Oh, it rolled underneath. Got it. Okay. So if we take one of our wires, I'll take the black wire first, and then get our little connector here. So right next to where it says C, that squarish port right next to where it says C, that's where I'm going to plug this in. Now this one, I'm going to stick it in as far as it goes, and I made a mistake. So compared to all of the other things we've been stripping, this one, you can see that's pushed in all the way, but there is still some metal showing. That means I stripped too much of the wire by about that much. So if you eyeball about that much, I'm going to clip that much off of here. And then let's put it back in and see if any wire is showing out. You do not want to see any bare wire sticking out there. So now we're good. Now we see the insulation. So now I'm going to go with the screw into that top screw above the C port where I plugged the wire in. And tighten that down as much as you can. Again, give it a tug test. Looks good. Bet you the red wire was stripped too much as well. That would make sense because I did the red wire even more. So yeah, I got a bunch of red wire excess that I'm going to trim off here. Okay. And then the red wire can go into the port labeled V, or underneath the V. Next to the V, I guess, technically, if the V is right side up. There we go. We're in. And I don't see wire sticking out again. So now I got to just make sure I'm holding that in while we get it started. Screw in from that screw on the top. And tug on it. It's not going anywhere. Cool. So now we can plug this back into our RoboRio. So I'm going to do... The V and the C should be facing away from all of our USB ports. Plug that in. It also only fits one way, so you can't accidentally plug it in backwards. It just will not go in if you're trying to do it the wrong way. All right, and then let's screw these connectors down on the sides. That will lock it down into the board, so now it can't unplug. So that is now in there for good. All right, and now we got to route these wires. So leave ourselves a bit of a loop here to deal with. And then I think I'm going to go through here. Well, I guess we actually route it, huh? All right, yeah, I'm going to duck underneath the USB section here. Kind of get it passing through there. Maybe we'll add a couple of zip ties as we go. I'm running out of the tiny zip ties too. I'm kind of going a little crazy on this one. I'm going to zip tie this to the USB cable that's here. That seems fine. All right, give it a little bit of a whatever there. Then over here, I'm going to go under these motor wires, I think. And then under this set of motor wires. That seems pretty good. Just don't know if I want to let it run underneath the board. Probably is fine. Right, we'll come out to here. We'll use ourselves a little bit of a loop, and that's where we're going to cut it. Then we strip those wires. Get in there. Got it. Okay, and now this one works just like the other one, right? There's a hole underneath where we are trying to plug this in. There we go. I found it. All right, and then just lower the lever for that one. Pull on that. That's not going anywhere. All right, and then we got the other one to go. Lock that one in. All right, and then let's see. What we can do here. I'm going to do an anchor. Pre-zip tied anchor, because I'm learning. I'm going to do this right about by the channel here. Again, just to keep the wire, make sure it's not going to ever rub against that. One of our cut pieces. That might be good. I guess I'll do one more around these motor power wires that we have here, just to really support this edge. But it's not really going anywhere. Perfect. Okay, let's go ahead and trim these as best we can. And our one little one over here. All right, that is RoboRio power done. Thanks for reminding me to plug the USB back in. I didn't forget. And okay, what's next? Next is the CAN wires for our SparkMaxes. So let me grab those boxes. All right, and so inside these boxes, we've got a bunch of extra stuff. Careful not to lose any of it. There's a USB to USB-C cable. That's cool. You're going to get one in every box. We definitely do not need one from every box. All right, also inside here are 2 plastic clippy pieces. We definitely want both of those. So I'm going to set those on there. And then there is a CAN set of wires and a just white and black wire. This is for PWM. You need the CAN one, so we need the green and yellow one. And then we need that from the second box as well. Okay, so little plastic piece, big plastic piece, and yellow and green. All right, now on our SparkMaxes, I kind of buried this one, so this was not maybe my best plan, but okay, cool. We can raise it up enough, I think, to get to stuff. Also, I could unplug it from the hub if I needed to get more access to stuff. Step number 1, on the top, there is a port here with a bunch of little metal pins that you can connect stuff to. We're not connecting anything to it. We don't want aluminum shavings or anything to get inside there when we're working on the robot. So the small plastic clip has like a little round handle, and that will line up with that spot, and you should be able to push it in. And this will go in, I think, either direction. I think it's not directional, so just shove that in however it goes. And then next, on our CAN wire, there is the white connector, and then we got the black connector. The white connector has a little ridge on one side. It looks like a little U shape in the middle. This side is just smooth. You can sort of see the pins in there. So it's going to only fit one way. But if you find the side that's V plus and V minus, there is a port there for USB-C, and then next to that is the port that this goes into, and you need that extra U stuff facing down. So it's going to just line up on that port. And this one's a little tough because like you really got to like reach in there with your fingernail or a screwdriver to push it in to make sure that goes in all of the way. You might be able to like, get a pair of pliers to push on the edge of the plastic housing as well. So whatever you got around, but make sure that goes in all the way. It's a tight fit to get that to go in. All right, that's one. That one we don't need to access anymore, so I will now try to get that back down to its little home here. That wasn't bad at all. All right, and we've got these 2 green and yellow wires coming out that we're going to have to do something with. Now, on the other one, we got our other SparkMax up here in the front. We're going to kind of repeat the same thing. So I'll pop it out. This one's super free to pop out and move around. I should have done this one first so you could see better, but too late now. We've come too far. Plug the little cover in the top. And then on the side where it's V plus and V minus, right, we have the USB-C port. And then to the side of that is where our CAN cable is going to plug in. And again, you got to make sure you really push that in. Sometimes I can get it with my finger, the fingernail in there, and sometimes I can't. So if you can't, find something that you can use to push the ends in. Little screwdriver works, little Allen wrench works. Obviously, the points of my needle nose pliers works. Okay, now we're going to stick that back where it came from. Can't tell if that's perfectly lined up, but that's fine. It clicked in. All right, now we have our CAN wires coming out of our two SparkMaxes. And what we want to do with these is we want to connect them together. So your choice which one's which, but we can take one of them and take one from the other one. I'm just taking the ones that untwist the least. And we're going to this time plug them in as they're shown. So yellow to yellow and green to green. Now, I know I said, hey, I don't like this way of doing it when we were doing the other ones. That's kind of still true, but that's what these clips are for. So these white clips, you can slide onto the end, and that will lock them together so they can't unplug. So these white clips make it a little bit better. They definitely work better than just the tape that I was using before. So we're going to live with that for these. All right, and so now these two things are connected together. We can find a good place to route this wire at some point, probably just on the top of everything else. I don't know. That's fine. We'll leave it up for now, and then we'll route it in a second. Now, the other two ends of our CAN network, this is our second CAN network, by the way, have to go into the RoboRio. So I'm taking my other wire over to the RoboRio. Right next to the thing we plugged in, there is a port labeled CAN. That's where we're going to have to plug those in. And then the other ones from our other SparkMax are going to have to go into the ports on our power distribution hub we have basically the same lever things that we just did. So they're yellow and green here. And these are for CAN connection as well. So this is going to be on the RoboRio's CAN network. It is slower, right, than the Canivore and the CAN FD for our across-the-road stuff. But we're not really sending much information to these. This is a very simple, this is the KitBot part, right? Like, it's a very simple mechanism that's going to be, we're basically going to be like, hey, turn on with this much voltage, turn off. We might do some current limiting, but it's not like a lot of data is passing back and forth. Whereas with our Swerve modules, like the steering angle, we want to get that information and update it as fast as possible. That's going to give us the best response time when you're driving the robot. So that's why we're on the faster CAN network for that, and then this one we're just using whatever's left. And these devices aren't able to communicate with that CAN FD protocol, so they have to go on the second CAN network. All right, what we're going to do now is, I guess we'll start on the RoboRio side. I'm going to I need almost all of this wire. So yeah, if you're a little bit too far away and you can't do that, you can pop this off, and you can shift it over a little bit and then Velcro it back down a little bit closer. That is an option. You can also, of course, reset the Velcro and stuff like that. And worst case scenario, yes, you could just get your connectors and extend the wires out. All right, but this is going to reach for me, so I'm going to just snip this. I'm going to snip it really close to the end. Just because I need all of the wire this time, I'm going to snip it right at the end. I'm going to make this connector basically useless. All right, and then we are going to untwist them a little bit so we can strip the green wire and the red wire. Green wire and yellow wire. There is not a red wire this time. I think I was looking at this red wire when I said that. All right, and then these, again, these are the much more stranded ones. So we'll see if it works, but these are the ones where it could be a little bit hard to push into the port here. So we can go with green into the L port. And just like on the Canivore, right? In theory, you can just push these wires in, but sometimes with these multi-stranded ones, that it went in partway, but it's not going in easily for me. So I am going to go ahead and push the button down and then pass that wire in. Yeah, that felt better. And tug on it, not moving. All right, now we're going to do the same thing for our yellow wire. Make sure it's labeled, right? So L green is the top one next to where it says CAN. H yellow is the bottom one. So we'll plug that one in. And again, if you have any extra wire, exposed wire sticking out, you might want to trim that down, but looks like mine went in far enough. So that is now, our CAN network starts at the RoboRio, goes through the first SparkMax, goes to the second SparkMax over here, and now we have this wire that we have to terminate into our power distribution hub. And again, it looks like we need, you know, I could definitely trim this a little shorter, but I'm just going to take all this wire. I'm going to go ahead and cut it right at the connector. We have all the other connectors we saved, so if we have to sacrifice a couple, we'll sacrifice a couple. I did also say those connectors I'll probably never use, but I might. All right, strip the ends of these wires. Okay, and then this one, there are two pairs here, right, for us to plug into. So we have two sets of yellow and green. Make sure you use two that are next to each other. So either the two on one end or the two on the other end. Don't do the two in the middle. Although I think technically if you did the two in the middle, it probably would work, but don't mess with that. All right, so we're going to do lift the levers up, push the wire in from the outside. There's a hole on the bottom, just like all of these other connectors we've been using. And same thing for the green one. Give them a little tug. That's good. All right. I have only a couple teeny tiny zip ties left. Is there anywhere we could zip tie this that would like accomplish anything? You know, not really. I'm going to bundle them together with these power wires that are running by here. That'll kind of help both sets of those wires stay safe. Yo, I just put that zip tie in backwards. My bad. Flip it over. And there we go. Okay, and then I'll use, do I even have another one? I'll use a way too long zip tie on this side. I kind of like the idea of just bundling it to this, our super massive power bundle that's here. Just to give it a little bit, just so it can't float around too much. And that's good. All right. Every device has power except one. And that one device, well, except two, technically. We're going to have to do our robot signal light, which is a blinky light, but that's going to connect to the fuel mechanism that we put in here. And the other thing that connects to the fuel mechanism is the robot radio. But the robot radio is just going to be connected by an Ethernet cable. And we're going to use something called power over Ethernet in order to power that. So we can get our power over Ethernet cable set up and ready to go. So when it comes time for us to hook that in, it'll be all good. So this will come in it's a Vivid Hosting power over Ethernet injector cable. And we can open that up. And the first thing that I notice as I go down here to show you where to put this in is that this long cable that I said I'll deal with later, I didn't deal with. So, you know, let's take a quick timeout to add a couple more zip ties. So I like the idea of, I'm going to just kind of piggyback it on the anchor that's down there to keep it away from the cut channel. Okay, that should do that. And then I I guess I'm going to pop this connector out. So you can do that. If you peel the plastic back, you can get the connector to come out. I'm going to go underneath these power wires. All right, green to green, yellow to yellow. Put the clip back on. Make sure it snaps in. Okay, cool. And then kind of route that in the space we left there. And that's doing a pretty good job of holding it in place. So I think that's good. All right, now back to the mission at hand. All right, our power over Ethernet cable has to do two things. And so one of them is it's going to plug into our RoboRio over here. And the other thing is these wires need to plug into our power distribution hub over here where the fuses go. Now, our things are too far apart to fit. There might have been a way to rearrange where everything goes that it would reach, but I'm actually not convinced that that is the case. Let's see. We can choose to have the radio attached to either side of the top of our robot later. So if I put this way, we can sort of be routing out in that direction, which might be good. And then we are going to have to extend these power cables to make that work. OK, so that's fine. Let's go ahead and get this. I guess I'll just attach it to the bank of wires that are here already. Okay. And I guess I kind of want to get on the, I'm trying to get on the, so there's a little bit of play in this. So I'm not on the actual box part, I'm on sort of the strain relief section there. But make sure you're not pulling too tight onto your RoboRio itself. That feels decent to me. And then clip that. We're going to need two more of our Wago connectors. So I think, yeah, so on here, these are called ferrules, and they're crimped on. And you know how we have that problem with the wire strands spreading out and stuff like that? When you crimp these on, that takes care of that problem. But they should still work if you slide it into the Wago. It's going to work no problem. So we just keep using the Wagos like we've been using. All right, and then we're going to need whatever we got left of our 18 gauge wire. And I'm going to just go ahead and, again, you can measure it out, right? It's going to go here. It's probably going to go around like this. So here to here, then around this way, right? And then into those ports. You can measure it out. My wire is so short now, what I'm working with, that I'm going to just kind of, I'll cut it when I get there. So I'm going to strip two ends, well, one end of each wire. Strip two wires. And put those into the Wagos. Looks good, looks good. All right, and then I guess we're going to add some zip ties as we go here. So those connectors are going to want to be about here. So let's get them. Let's get it anchored in. I wonder if I can I pass another wire through the frame? I can. Excellent. Can I do it facing the right direction? Yes. All right, we'll get these connectors up here where they can't move around on us. All right, now these wires, what are we going to do? Guess we need these to go at some point Is it better to go this way? Around? Yeah, I like that. I like that better. Now that we're in here thinking about it, because we have other wires going that way that we can sort of attach to. All right, so we're going to have to feed it under these motor wires here. Okay, and then under these motor wires here. All right, I'm going to clip this zip tie carefully, not to cut the wires if possible. That we just put in, because I'm going to want to get this one joined in with it. Right, these ones are being very unruly, so I'm going to grab, I'll grab the other CAN wire while I'm at it here. And I'm going to get everybody onto the motor power wires that are here just to keep it from going crazy on me there. And then I'm going to get that zip tie. And here, again, you could cut the one in the zip tie, in the zip tie anchor that's already there. But I'm just going to zip tie this right next to it. So that should do a good job of holding all these guys in place. All right. Okay, and then these wires are going to pop through. Guess we might as well go under that set, because that's the side they need to be on when they go in. All right, and then they need to go into there. So we'll cut it right about there. And once again, in the now hard to see location. Wait a minute. Make sure you open two ports that are on the same number. So it should be the next two open holes here. I almost did. One wire in one port and another wire in another port, which would not be good. We're in, lock that one down. And the last one. It's in and locked down. All right, tug, tug, tug. Everything is doing good. All right, I'm trying to think what else we haven't done. I know we got to put fuses in, so let's go ahead and do that. So we got our fuse baggie here. And I have some extra ones because, like I said, you're going to need some extra ones. So first, if you find the 20 amp fuses, we're going to find where we powered our CAN coders, right? So that was this first port here, 19. I'm going to put a 20 amp fuse in 19 for those. And these are going to be tight. You're going to have to kind of wiggle them back and forth. That is just the way that it is. Just make sure you go down. You'll feel it hit the end when you're all the way in. It'll kind of be the bottom of the board. And kind of, if you look down, oh, we got a, hold on. Got a stray wire lead here that I don't want to get. There we go. Didn't lose it. Okay. Inside here, there's sort of like little metal ovals or little metal connectors, spade connector areas. So make sure when you put these fuses in, like if you go in at a very steep angle, it is like in there, but it's not actually in the metal part that's connecting it. So if you put it in and it doesn't feel like, hard when you're going down, that's a problem. Also, make sure it goes in sort of straight up and down, and that's going to help you make sure you're in the connectors inside there. All right, and then our other one was this pack here, going to what looks like number 6 right here. And these circuit breakers, doesn't matter whether you put it in facing this way or this way. They work. I mean, basically what happens inside of them is there is a bit of metal that the current is running through, and that metal is, when it heats up, that metal will change shape, which will then break the connection. And so these are auto resetting breakers, which means when that metal cools back down, the connection will reconnect. So if you do pop one of these breakers, like on a drive motor, you're not done for the match. It's just going to take a second for it to click back in so you can start driving again. All right, and now we're going to grab the 40 amp breakers on the other side. It's kind of weird that the 40 amp breakers are smaller than the 20 amp breakers, because you would think bigger number, but not in this case. Uh-oh. Can't lose these. I need all of them as I proceed to lose more of them. All right. Found them all. All right, so we have our 40 amp breakers. You'll know because they're labeled 40. I guess I didn't mention that with the 20s, but it does say 20 on top. All right, we need a 40 amp breaker on each of our drive motors. So we have the drive and steer for each module. Each one needs a 40 amp breaker. So it's going to be the and we need one for our 2 SparkMaxes. We're not using those yet, but those will be sim motors, which will also need a 40 amp breaker. So basically everywhere else that we have wires plugged in, you need one of these breakers. Now these are a little, I found that they're like a little fragile too, so I don't want to grab the sides a lot. I want to make sure I'm pushing down on the top. Unfortunately, that does mean I can't really do this and let you see what's happening at the same time. But we're going to go into each one of these ports again, make sure it gets into the ovals. And it is hard. You got to do a little bit of wiggling, push on one side, push on the other side. All right, so that was 2 of our drive motors. This is one of our, going to be one of our fuel mechanism motors here. That one's very tight. There we go. Got it. Now, it's probably a good thing that these are tight, though, because right, like you want a good, solid connection. All right, jumping over to the other module, we've got a couple here. Again, doesn't matter which direction these are plugged in. Okay. Right next to it is another one from that module. All right, then over here, we have, again, 3 in a row. So it's going to be, after our 20 amp breaker, 3 more. So for our front module and our other fuel mechanism motor, come on. Okay, there we go. That one was real hard. Next one. Okay, and again, you'll be short on these breakers a little bit, so you're going to have to buy some more. There are a number of different suppliers that sell them. So I think you can follow the card in here to get more from Snap Action, which is the type we're using here. But some of the other companies make them as well. I don't know if Cross the Road Electronics makes one or not. I think Rev might make a 40 amp breaker that fits in here. And check the rules. Make sure you are using a legal one. I don't think this is a part that you probably can't just go on the internet and be like 40 amp breaker, and if it fits, you're good. You got to make sure it's one of the approved ones. All right, we got 3 across there, and then we have our last 2 for our front right swerve module here. And the last one. Okay, that wasn't too bad. All right. All of our breakers are in. You need your power distribution box inside of here. There is also a little baggie with some blade fuses. These are, I think, just automotive fuses. So if you need more of these, you can just go to like whatever your local auto parts supply store is. But in here, there are 2 different kinds. So we have red ones and blue ones. The blue ones are 15 amps. The red ones are 10 amps. We need the 2 red ones, the 2 10 amp ones. And those are going to go into, right, we used the little levers here. So our radio power injector, power over Ethernet injectors in one of them, and our RoboRios in the other. And both of those need to be a 10 amp breaker. So again, this one is really easy to miss, but it's also really easy for you to look down and see because it's not as deep where those little oval metal things are that you need to make sure you're lined up with. And with this, make sure, like you push it in, it'll sort of stop a little bit. That's not all the way necessarily. Make sure you really get that seated all the way in, because a loose breaker here or a loose fuse here on either the RoboRio, which is like the main computer, the main brain on the robot, or the robot radio, either one of those flickering a little bit is going to mean you lose complete control of your robot. So these are super critical. All right, make sure those are pushed all the way in. And we definitely have some more wiring to do. We know once we have the fuel mechanism in, we're going to have to wire those motors up, and that's what the radio and the robot signal light mount to. So we're not done with wiring, but we're done with wiring for this video. We have the entire chassis wired up. Everything is prepped for the other stuff. Now when we put the big hopper in and cover everything up, we only have a little bit of work left to do in areas that are fairly accessible. Of course, you could put the hopper in, take the hopper out. You can work under the hopper. You can do this in whatever order you want. But I like having the nice open, easy access to everything as we were building here. All right, that's going to do it for this video. We'll see you in the next one. But before we go, we're going to give another special thanks to Argosy. First, Cross the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School for hosting our studio.